has changed a bit since last time, so it's going to take me a minute to just check everything out, but I think we are live. As usual, we are streaming on YouTube and on Twitch and on diode.zone. Specifically, it's sort of a relatively low-level live streaming experience at live.diode.zone/scanline. If you're a fan of the raw HLS experience. Anyway, hi. I'll be keeping an eye out for Tuco, getting him back on camera whenever I can. Oh, this would probably be better if I actually turned on both of the microphones. I should be significantly louder now. Anyway, hello. Welcome back to the stream. So, it's been a little while since we've done one of these. I think the last time I did one of these streams, I was working on this sort of modified sewing machine, trying to get it ready to sew masks for this current pandemic that we find ourselves in, that's now dragging on longer than I think most of us expected. And this year continues to be weird and terrible, but somehow I've got some motivation to do something that might be potentially useful with computers. So I'm back here on the internet doing a computer thing with all of you. So we'll see how that works out. And I'll try to be keeping an eye on the chat platforms. I've got our usual kind of YouTube and Twitch chat built-ins. And I don't know, I feel like the Gitter chat is slightly deprecated at this point since a lot of folks have been moving off of Gitter, but I am trying to pay attention to it, so there's that. And it looks like some folks are showing up on YouTube and Twitch already. Hello, hello. So yeah, a lot of work on the house and the streaming setup and everything since last time. Always hard to get all this text on the screen. Yeah. So so we're back in the new place. I don't know. Some of you might have missed the entire move situation that happened this year. So end of last year / beginning of this year, I was house hunting and moving cities and just generally trying to get myself into a situation that was less terribly expensive than living in the Bay Area. And so now, I didn't move too far, but I've got a spot that is significantly less terrible for the mental health and the money. So I've got a place to live here that's pretty stable for me and Tuco, and really my only excuse not to be bringing you constant electronics content 24/7 at this point is that it seems like in this hellscape we're all stuck in, the electronics content is the least relevant thing possible. But maybe we should talk about that, because maybe there are some ways that we can take some of that energy and use it for something that is helpful in some context. So I've got a bit of a weird project. Some of you might have seen me posting about, I don't know, just weird operating system stuff and Rust stuff. Part of it is I have been enjoying Rust. I feel like there's a lot of computering that I'm pretty burned out on at this point, but Rust seems to be an interesting combination of it being a language that is capable of doing a lot of the fiddly low-level things that I enjoy, but also a community that actually seems pretty welcoming and just generally not terrible, which is pretty rare in low-level systems kind of programming. Yeah, Jared says they're also finding it very difficult to care about things in the current climate. Right, it's just very few things seem super useful. I mean, that's part of why I wanted to point out that there is at least one thing that is fairly well defined that everyone can do, which is everyone should be voting if they can. if you live in the US, if you're in a place where you can vote, like doing that is helpful. And it might not be easy depending on like where you live. And so like having all the right information and having a plan for that is pretty important. And so actually kind of related to that, there's a couple of projects that kind of point out that that necessity in a way which might actually get to some of these like tech audiences that I find myself like still in, that I'm not sure how to interact with. So actually the first one that I found was, some of you might know the channel Blitz City DIY. They post, Liz from Blitz City DIY posts a lot of great videos on YouTube and on Diode Zone, which I want to talk a little bit more about on this show too. But, so Diode Zone is this an instance of PeerTube, which is something we'll get more into, but it's basically just like a way of running a video site that is small. It is not the size of the entire internet. It is just something that can be an arbitrary finite size for like you and the things that you care about or the people that you want to invite. And because it's federated with other servers using this protocol ActivityPub that you might have heard of from Mastodon, the idea is that you can kind of create your own small video site that's sort of like, not a YouTube, but like something that's trying to be a reasonable size with like humans doing the moderation instead of unaccountable algorithms. And you can, make these like human scale video sites and still have them connect to each other and share content and to some extent share technical resources. Some of that could work better, which is part of why I think that it might still be worth doing some technical stuff. But like for example, Liz has been putting these videos out.
Awesome. What? Voting.
She reminds people.
Love voting. You get
voting is
pen,
awesome.
You do all the marks, you get a sticker, participating in the democratic process, fulfilling your civic duty, all that. Super good stuff. The only bummer about voting is I just feel like I always have all these questions, like, when am I voting? Where am I voting? Luckily, there's resources that can help answer all of those questions and even more. Places like vote.org, they're a nonprofit that has everything you could ever want to know about voting listed on their website. Voter registration, all the ways you can vote, and even deadlines and guidelines by state. Well, it says here the next election's November 3rd. That's pretty close. That's right. Tuesday, November 3rd, 2020. Probably one of the most important elections of our entire lives. Please vote.
So I'm here to plug Liz's video, not steal it, but you should definitely check out her work, especially like this project is super cute. But yeah, she's been posting some great stuff on YouTube and even on my little home away from YouTube. And then I also wanted to plug something that I think is super useful that like an IRL friend of mine made just recently. So if you go to usa.votingdeadlines.com, there's a handy map where for every state you can click. So we live in this place over here, which is on fire. And so it gives you links to all the official sites, gives you kind of quick, like kind of traffic light style kind of indicators here telling you how much you should worry about various kinds of registration, and you can get more information. And the registration deadlines can get kind of complicated, but this tries to represent sort of a reasonable amount of complexity and show you like, oh, there's more than one way to do it here, but try to simplify it enough that you can still see what's going on. And you can see the swing states and stuff that's ending soon, for example. So, and actually, my friend who made this is here IRL. I don't know if they want to say anything about it specifically, but we could bug them with questions.
Yeah, there's two reasons I wanted to make this. One is I kept going to other sites like the one in the video you just showed, and they typically display the same data but as a table, so it's just kind of more boring to look at. And so I wanted to make something that highlights the stuff that's ending quickly and maybe highlights states that are more consequential to people. So like Rhode Island ended recently, but I don't think there's really a competitive Senate election, and the presidential election is not very competitive there. And then on the other hand, I kept seeing a lot of data on all these different websites, and I wasn't positive it was all up to date because a lot of it keeps changing. So I'm scraping a couple different websites and trying to make sure that my data and everyone else's data is actually up to date. And there were more issues a couple weeks ago. I think today pretty much everyone is on the same page about 95% of it. But Arizona, for example, got pushed forward recently. And there's some other minor things that I was tweeting about.
Yeah, I should plug the Twitter for this also. I think it's voting deadlines on there too.
Mm-hmm. So Nevada, for example, technically closes registration, I think already in person, and yet I think that's just at like your county clerk's office it's closed. But if you go to early voting, you can just register in person same day and vote. So effectively you have all the way up till election day to register in person if you want to do it in person. So little details like that I've been trying to clarify.
This is super important to get information on, so yeah, I hope folks find this and find it useful. And it's also open source if you want to check out the code. It's on GitHub now.
Yeah, I'm not so experienced in TypeScript that it's good code probably, but I have been finding TypeScript pretty useful to try to make sense of the data. I think if I was doing this in JavaScript, it would be a lot messier.
That makes sense. Oh, and it looks good on mobile too. This is not a good illustration, but yeah, it's pretty easy to use on your phone. You can grab the state and check it out. So yeah, someone on chat was pointing out that it's a sad thing that that like people have to make websites like this, and it isn't just like the government like providing information consistently. But I mean, yeah, that's
So most of the data comes from vote.gov, and that website is open source. So if you click the links on my website, you can see sort of the general source code of it. So this is the website. And actually, that link towards the bottom, how to check your voter registration, they just added those in the past couple days or a few days. Scroll down to the very bottom.
Oh, of this
of voting deadlines.
Oh yeah.
And then click the vote.gov data link.
Oh yeah.
Yeah.
Oh
So
yeah.
this is like a JSON file in the repository. So probably 95% of the data is just this without alterations, but then maybe 5 or 10% of it, there's some discrepancy between that and other data I've found, like on voteamerica.com or vote.org. And most of them at this point aren't super important. Some of them are in the past. But things like the Nevada in-person registration, some things like that. So it is open source. It is reasonably up to date. But yeah, it is kind of messy. It's so many different states have a lot of little quirks that make it hard to think about. Like New Hampshire, it's pretty convoluted. But North Dakota, for example, in a way, North Dakota does it better than a lot of states because you don't have to separately register. You just have to prove residency at the polls. So there might be sort of additional barriers in a certain way, but there's also less barriers in the sense that you don't have to go through a separate process. And so a lot of countries do it more like that, like they have automatic voter registration.
Yeah, there are a lot of different systems because all the states have to be states. Well, yeah, so make sure you're registered and you have a plan for voting where you are if you're in a place where you can vote. And yeah, I mean, other than that and trying to do like whatever kinds of like local support and just getting connected with people as possible. Like I feel like I've been completely failing at doing that lately. Like I was doing some amount of protesting earlier this year, but then kind of got super distracted by having to like fix up a bunch of house stuff, and now I've mostly been back in hermit mode. I've done some video editing. I don't think I've really made anything that I'm like, I feel like I've got all these pieces that are each maybe like 20% of an actual thing I'd feel happy to release, but like I've got this bit of edited video from I don't know, making a bit of this sort of little button panel switcher for my streaming setup. And you know, it's cute, but like completely irrelevant. Like no one needs electronics DIY randomness. I mean, but then a lot of that's me being negative because I know I'm interested in other people's electronics DIY randomness a lot of the time. So anyway, this is part of why I thought it was interesting to get some motivation to do a bit more work on decentralized video. Because even though, you know, I haven't been as motivated to produce the video content myself, I really like making a place where people can upload stuff that they make, and having a way to just like foster the creation of communities that are smaller than the entire internet and are moderated by humans and use technology that can fit on like a single computer or a couple of computers. Doesn't require a computer the size of a continent, you know. So, you know, just generally not having to rely on Google for things seems like a difficult but worthy goal, and being able to do that for something that, you know, that I have some experience and, you know, maybe care about sometimes, like with video, seems worth doing maybe. Oh yeah, I agree. Jarrett says the emojis on the states are a nice touch. Yes, I think those add a lot of charm. So yeah, I got kind of deep into doing some software work on like peer-to-peer video the last couple weeks, because I got to talking with my friend here about maybe getting more serious about building a I don't want to say competitor to PeerTube, because it's not that I want to compete with PeerTube, it's that I want to experiment with a software stack that is compatible with PeerTube, but maybe focuses on different things in its design. So maybe something that uses like somewhat more modern web frameworks, and something that focuses on like accessibility a bit harder, something that has like a video storage backend that is just like built from the ground up for streaming and for like a variety of transcode formats that might not all be like known at the beginning of time, you know, distributing the load across multiple servers, that kind of thing. Like right now there are just a lot of things that I would like to be able to do logistically with Diode Zone, for example, that like PeerTube doesn't have a facility for. Like if I just wanted to move all of its storage to a different place temporarily or permanently, and I wanted to sort of like add an additional bunch of disks to it, there's no, like PeerTube gives you no help there. It's just a standard Linux application, really. So you can use Linux tools, like you can try mounting network file systems over your local file system and updating the disks and, you know, whatever, that kind of thing. But wouldn't it be great if the peer part of PeerTube actually meant that you could just stick on more servers, and you wouldn't still be stuck relying on the single point of failure on the single server that has all the data. So like generally my feels with PeerTube is that I'm like really glad that it exists, but I feel like the peer part of it could work a lot better. And so I've been trying to figure out how to accomplish that, really. The peer systems in PeerTube are even a bit weird and complicated, because there have been multiple of them over time, and the specifics of how you're getting the video can change depending on how the server operator has configured their instance. So like you can look at the PeerTube website to kind of see what their promise is. Like it's peer-to-peer and censorship resistant and all that, and I really like what they're going for. My experience running PeerTube is mostly that the systems that exist to try to allow multiple servers to increase the reliability and decrease the bandwidth load don't actually work that well right now. I mean, I don't think they've really had the resources to make that part of the system really robust. Like right now, PeerTube is more like a video content management system that supports ActivityPub, which is useful on its own, but like the peer-to-peer parts of it could be stronger. So I've been thinking about like what are the options to try to improve that a bit. So what peer-to-peer systems do they try to use right now? What else is out there? So like right now, PeerTube has really 3 separate ways of delivering video that you could think of as allowing servers to collaborate. There's or multiple clients to collaborate, peers to collaborate, ideally. There's a way for sort of these big single file videos that they originally started out with to be distributed over web torrents, which are really just BitTorrent packaged over WebSockets and WebRTC. So you can do that. That was the original system that PeerTube was released with. I think it started out with just that. It's like hard to say how well any of this stuff works because there are not really good network test beds for any of it. Like when the WebTorrent folks are trying to demonstrate how well their technology works, they have a demo page with one copy of that Big Buck Bunny video that everyone uses to test their video software in like 480p. And so you have thousands of people downloading the same 480p video. It's not a very good test. Like you need to show that the peer-to-peer is going to help with common cases that video operators are going to experience. So I mean, I wasn't super impressed by that, and it didn't seem like there were test cases in place that would allow the PeerTube folks to see where the web torrents were failing and where they weren't failing. So that was like my first impression kind of coming up to PeerTube when it was like pre 1.0 and that was the state of things. And I was hoping there was a path to improve that. The way things stand now, though, I don't know that WebTorrent has really gotten much better. They just added 2 additional systems. So now there's additionally a system called the Novage p2p HLS loader, which I think actually has a site here that might be worth bringing up. So this is actually the peer-to-peer engine that that PeerTube is usually using if you view like Diode Zone, for example. Again, some of this stuff is confusing because it can depend on how the server is configured, but PeerTube originally had that WebTorrent mode, and then largely because the WebTorrent style videos are very slow to load if they're really long, they added a different mode where the videos are natively stored as HLS, like HTTP live streaming playlists, which means that you can kind of natively split them into reasonably sized segments that can be loaded independently. You never get stuck having to load like 40 megabytes of video index data just so that you can start playing the first second of video. So HLS prevents that from happening. Yeah, it's not clear how well most of these things work. Like P2P Media Loader is not something that the PeerTube folks themselves maintain. It's really a separate project that PeerTube kind of drops in. So it's designed to allow multiple web browsers that are all viewing the same video to share parts of that video. And it doesn't need much server support. It uses a central tracker, which I believe doesn't have to be connected with the project at all. So I think all the PeerTube clients are using just like the default trackers that are packaged with this P2P Media Loader. Because they don't need to know much. They just like exchange context, or they exchange contact information based on the hash of each video block. So someone can call up the tracker and say, who do I call to get one of these video blocks? And it'll give you information about getting to that other client over WebRTC. The server, so PeerTube is mostly responsible in this case for just providing hashes of all the video segments so that the clients can ensure that they're getting valid data from the other peers. But otherwise, it's pretty like simple from the video site operator's point of view. So this is like compelling because it's easy to integrate, but it's not clear how well it works. It doesn't really solve the use case that I think a lot of server operators care about, which is that, you know, you want to be able to have a community of other server operators and moderators that is maybe smaller than the entire internet, but bigger than one server. And if you have such a community, you might want to share technical resources. And this doesn't really give you a way to share resources between servers. This is entirely on the browser side. So PeerTube has a third system for sharing resources between servers, which also has its own problems. And this is something that PeerTube created themselves, or specifically for the project. It's they just call it the video redundancy system. It's just a way for the servers to communicate as part of the. I could be wrong about this, but I believe it's part of the ActivityPub video object. They just include a list of redundant video hosts for each video. So in addition to getting the video from its home instance, you can get it from a bunch of other instances that have volunteered to provide the video. But this is sort of the worst of all the systems right now because nobody's verifying that the videos are correct or that they can be retrieved reliably. And the client right now is just very bad at giving up quickly and trying a different server when it turns out the one server is actually slow. So this is like the one that I've been most excited about actually using on DiodeZone, but I mostly can't use it in practice because one slow server offers to mirror my video, and all of a sudden my video is slow for most people.
Do you know what those percentages mean?
Percentages. Oh, that's a good question. I'm guessing that's somebody's optimistic projection over how this might work. I'm curious if that's actually been measured. I mean, it looks like they're claiming that you might have to have 80% of the traffic, or that you might only need to supply 20% of the traffic from your central server and you get 80% from other clients. But like all of this has got to depend on a number of factors, including like how long your video is and how many of your clients are desktops versus how many of your clients are mobiles, and how much memory your clients have. Even like a lot of the clients aren't even going to want to store much video, much less spend the bandwidth to send it to other clients. I haven't actually looked super much into like who else is using this actually. But I remember looking at this recently and noticing they had support for other video players, like this relatively recent player called Shaka that Google released, which I had thought was mostly a Dash thing, but it looks like they also have HLS now and support for this. Well, and this even supports Dash now, so like everybody's just writing more code and supporting more things. So yeah, I mean, I guess where I'm at with PeerTube is that there are a bunch of these separate systems, and it leaves me wanting to think pretty carefully about what data models might work well for several different ways of distributing the video so that you can kind of make minor changes to the plumbing in a system like this without having to completely change the data representation. Because what I'm seeing now is that PeerTube, like if you have a fully decked out PeerTube installation with everything turned on, you're using probably 4 times the amount of storage that storing just the videos would take, because you're storing them in several resolutions and you're storing them both in HLS and in the non-HLS WebTorrent file format. So it's not great, and I feel like if we kind of keep throwing additional ad hoc peer-to-peer systems on there, it's just going to keep getting worse. So I'm kind of interested in shopping for a less ad hoc peer-to-peer system. So that led me to looking closer at IPFS and the protocol formerly known as DAT, which was recently named Hypercore, Hyperswarm. If I remember correctly, their network protocol is Hyperswarm and their storage protocol is Hypercore, but I could be remembering that wrong. Anyway, just kind of trying to look at, what are people doing in the peer-to-peer world of things that actually work. Um, Peer-to-peer, I mean, it's anybody who grew up in the 90s looking for like music on the internet's probably tried a lot of half-baked peer-to-peer systems. Um, I mean, it's a hard problem because there are a lot of things that work against you. Peer-to-peer is usually at odds with reliability and privacy and latency. So if you want to make a video site that can effectively utilize resources from multiple collaborating servers or multiple collaborating peers, like you're probably going to give up some kind of privacy. You're probably going to give up, some kind of expectation that all your videos are going to start quickly or in a predictable amount of time. So that kind of opens up new challenges in designing a user experience that people don't hate and designing protocols that make the best of a difficult situation. So, IPFS and DAT are both pretty interesting. Is my audio cutting in and out? Can't tell whether that's me or not. Catch up on chat for just a minute. Yeah, automatic voter registration would be pretty great. There are just a lot of people that don't actually like it when people all have the right to vote, which is a big part of the problem. Okay, I guess the audio is not terrible. I think I was just getting confused by the headphones. Cool. So yeah, there's part of the problem with peer-to-peer though has always just been that there's so much hype. Like if you look up IPFS, it's mostly cryptocurrency hype and just terrible like nonsense. Like there was even an issue on the PeerTube bug tracker where we were talking about this. Lots of people who... So, I'm actually kind of curious what the average hardware is that people deploy PeerTube on. I get the feeling that it's some kind of relatively inexpensive, like shared host kind of machine or like a virtual machine, or maybe a container. But like most PeerTube servers don't have huge amounts of storage. It would be cool if the smaller number of PeerTube servers that have access to like big banks of disks directly could help with the storage needs of some of the servers that are running on virtual hosts. I think also folks have talked about wanting to have tiered storage so they can have some local disks and then some stuff that's stored in like Amazon S3 or whatever, which is certainly not ideal if you're trying to get away from cloud hosting. But sometimes you need overflow space, and it can be nice to give administrators plenty of options like that. So this has been open since April 2018. IPFS to store videos. And a lot of it's just like, could we try this? Some skepticism, which is pretty justified, but we have no use cases for IPFS. I don't really get that, but. And then somebody brought up WebRTC up there, which is also interesting to consider, because like, how do all of these things interact? Like, there's WebRTC and WebSockets and IPFS, and like, oh, there's so many protocols. But I think it's useful to think about things like WebRTC and WebSockets as like the platform that you're building on for the web. Like those are just these like fixed components that are very difficult to change unless you are part of a consortium of browser manufacturers, which isn't impossible, but that takes a lot of time. So like we have our WebRTC, we have WebSockets, but there's this other layer that you can build on top of that, which is how do you get streams from point to point? How do you route the content? How do you figure out like who has what data? So if you're doing kind of a smaller scale, kind of more traditional like WebRTC application where you're doing video from peer-to-peer, like something like Jitsi, Big Blue Button, those apps still have servers, but they do use WebRTC to send a large amount of the data pretty directly from peer-to-peer. Those kinds of apps are there's some limitations there, first of all, that you run into pretty quickly because you are sending all of the content from every peer to every other peer that's interested in it. So, that's why if you are on a tool that is purely peer-to-peer and you're trying to do like a large video conference, then it's going to use a lot of web bandwidth and probably won't work too well because you don't have like a central component aggregating all the video. But if you're on a Zoom call and there's a bunch of people in the Zoom call, then Zoom's got a server somewhere that's actually aggregating together all that video into a smaller number of video streams. So there's a lot of space between like a cloud computing experience and a decentralized computing experience that all like use the same protocols. Like it could all be WebRTC or WebSockets or whatever. So, like what is really going on with something like DAT or IPFS, like this kind of current generation of decentralized protocols. And like a lot of that is around giving people a way to publish content. It's, if you drill down to the very lowest level of either IPFS or DAT, it's like, how do you represent data and how do you name that data? So IPFS is pretty compelling to me because it's just so simple at that level. There are little bits of the protocol that add some complexity in order to retain forward compatibility and backwards compatibility, but at its heart, it's really just a way of referring to data by its hash. And it's just a database that maps the hash of some data to that data. So it's got a bunch of layers that you can take or leave on top of that. Like you can make those hashed blocks kind of behave like a Unix style file system. And you can have an HTTP gateway. You can access them from JavaScript. There are a lot of pieces that people have built that fit into this infrastructure, but at its core, it's mostly a data representation. And then the sort of DAT hypercore protocol is also a data representation at its core, but they chose something slightly more complicated. Instead of that just like immutable connection between the digest of some data and the data, they have a system that's based on public-private key cryptography so that you can change data after you publish it. You can append to it specifically. So that makes it significantly more like just useful right away without having to add any extra layers of protocols. But it also means it's more complicated, and I think maybe as a consequence of that, it's been taking them longer to get just like the basic pieces of it kind of stable and sort of standardized. Whereas I think IPFS is already at this point where there are just a lot of fairly stable libraries that people have built that let you send data back and forth and give it a name and figure out where that data might live. So I had this idea for a proof of concept where I just wanted to see what it would look like if I tried to make a video ingest server that took data from like whatever live stream source. In this case, I'm just using anything that FFmpeg knows how to read, and splits that data up into HTTP live stream, like HLS compatible segments, and stores those segments in RAM, just like a regular live video server would. And this proof of concept doesn't do this yet, but like I would want that server to also just be able to provide those video blocks directly back out to clients over HTTP, over maybe RTMP. So something that acts basically like a normal live video server. But in addition to being a normal live video server, as soon as the video hits the server's RAM, it gets named in a format that IPFS knows how to store. So we split it up into blocks that are smaller than IPFS's maximum block size. We hash the blocks in SHA-256 and pack the hashes into the right format and create playlists that reference those hashes. And now we've got this thing that is both an HLS video and an IPFS resource, and you can just plug additional IPFS servers into there to mirror the data in real time. So, it's still super experimental. It's also still super inefficient because, peer-to-peer is always going to be less efficient than just unicast for the most part. But I think IPFS also probably could use some more tuning in general, and then specifically my usage of IPFS is, I'm sure, super unoptimal, and I need to come up with some more tools to diagnose exactly what the performance flaws are in it right now, but it's a thing. So yeah, I recently posted that even in its completely incomplete state on GitHub, just so that we could mess around with it a bit on these streams. I've been calling it rectangle device because it's, I think it's self-explanatory. So an experimental live plus video on demand server is the idea. Right now, it just takes video in and stores it in RAM. I'm not really making any attempt to permanently archive videos, except that I have kind of a very basic integration with a pinning service in IPFS so that it can tell the IPFS server to remember the data, but that's mostly just for testing the characteristics of that mechanism rather than intending that to be the main method of archiving stuff. So this has been an interesting proof of concept because it's opened up a bunch of fairly delicious cans of worms, including some video transcoding goodness. So this is also kind of related to a part of PeerTube that has been a constant annoyance of mine, is that they don't really take video transcoding super seriously. They've kind of haphazardly changed the transcode formats a couple of times, and they never store the original video files. If you want compatibility with both HLS and WebTorrent, you just have to store the data twice. And just in general, I feel like if I were accumulating 5 terabytes of video that I was hosting on behalf of other people, I would want just a better way of storing it than what PeerTube currently offers. I would want a way of migrating smoothly between different storages and between different formats. I would want a way of splitting up that load between multiple machines fairly smoothly without having to take the whole thing down. I would want a way to add additional servers and add redundancy rather than removing redundancy, or removing reliability. There's just a bunch of things that have been annoying about PeerTube's video storage system that maybe we could go into detail on or not, depending on how much folks are interested in that. That's an interesting question. Mitchell wonders if I'm using IPFS for anything else, and if it's worth using that as just personal storage. So I would say that if you're interested in trying IPFS, it's a really interesting peer-to-peer technology, but make sure you understand it to some extent before trusting it with important data. When you it's important to know that when you add a file to IPFS, it's not stored anywhere. You're just naming it. You're just creating a hash that refers to that chunk of data and remembering that hash exists. And then neither the reliability of that data, nor the privacy are guaranteed. In fact, putting something on IPFS is also just very, by definition, pretty public. So you can definitely use it for personal data, but you'd want to encrypt the data, and you'd want to make sure that you're not just adding it to sort of an ephemeral IPFS database, but you're taking steps to make sure that there are at least one IPFS servers out there that are on the network that actually have your content pinned, that actually feel responsible for holding that data. So yeah, I don't know if I'd use it necessarily for just like your everyday files, but for like a collection of public video files, like what most PeerTube instances are, it seems practically ideal. It's also interesting to look at like how people are already using IPFS. Unfortunately, it's just a lot of like stuff that looks way too much like crypto pyramid scheme scams all over the place, and people using it for stuff that just doesn't even make sense. Like I was reading this article, somebody was really excited about using IPFS to store. Okay, so this is like going into one of many like terrible rabbit holes of things that people are doing with cryptocurrency that are I don't even understand. But like, some people are trying to use encryption to sell digital art, which is just like a weird concept. It feels like, I don't know, like a way of scamming people who, would normally be donating to museums or something. I don't know. But it's like a weird, it's like this weird technical thing that I don't think does what people think it's doing. Like, there was some step where they were trying to sell this artwork, so they added the artwork to an IPFS server and then took the hash of that IPFS file and used it in an Ethereum transaction. So like what that accomplishes is it sort of like notarizes that transaction had some reference to those specific bits. So you could use it to prove that those specific bits existed at the time of the transaction, but it doesn't prevent anyone else from getting those bits. In fact, it like, if they didn't encrypt it, it makes it fairly easy for people to get those bits. So I don't really understand what they're doing with any of that. And the folks who work on IPFS, like they put a lot of interesting like peer-to-peer networking technology out into the world, but they've also got their own crypto pyramid scheme thing with Filecoin, which is like not really related to IPFS, but certainly the same people seem to work on it, and same people are funding it and all that. So yeah, I mean, I guess to answer your question, I'm not like using IPFS for anything serious, but I've been kind of evaluating it to see like what it's good for, and I've had some experimental video stuff running on it. I've had a copy of Diode Zone served on IPFS. I've been manually updating it, so it's probably out of date right now, but most of the files on Diode Zone, like if you made an IPFS compatible hash of them, you would be able to download them from that IPFS server. I just haven't been publishing those hashes for the most part. So yeah, I've got this like weird little proof of concept. I was going to talk more about transcoding, but maybe I should just run this thing. So I've got a shell script to start it up at the moment. It's got a bunch of command line options. So Cargo is just Rust's like package manager tool, if anybody is not familiar with that. I could be running the binary directly, and maybe it would be slightly more illustrative to do that. I think it was just being slow for a sec because it had to see if all my files were up to date. Target debug. We don't actually need that ding, do we? Okay, experimental video server. So mostly what this thing is asking for is an ffmpeg command line. This is not the entire ffmpeg command line, but like the portion of it that deals with input and transcoding. I guess we're already starting to open that transcoding can of worms, aren't we? So there are many things I could complain about with PeerTube's transcoding, but one of those is that it runs the transcodes as an ffmpeg user, like with the same user privileges as the entire web server process. Video transcoding is complicated. It's all written in C, and it regularly has security flaws that lead to privilege escalation. If you look at a lot of ways that people got their like Android phones hacked or whatever, it was by opening a media file that exploited the codec. So, if you look at larger video providers, folks like YouTube and Vimeo, they would not be running their transcodes on the same hardware, on the same, user account as their web server. That would be isolated somehow. Why don't people do that right now, though? I mean, I think it's largely because it's sort of annoying to set up. Like right now, if you want to run an isolated transcode in some kind of sandbox, the kind of industry standard way of doing that would be to already have some kind of container infrastructure, like a Kubernetes thing that you can just like send serverless functions to or something modern like that. And probably it's all modern and running in the cloud, and you don't actually know what any of the hardware is like, and you're just paying someone else like per transcode or something. And at that rate, why write any of your software at all? And, why not just pay for a service that does your transcodes? And so, like, that's what people mostly do. That's why most of the video sites out there, they're just using some software as a service provider to do their video transcodes. And if you're somebody big like a Vimeo or a Google, then you've built your own containerized transcode thing. And if you're a small operator running a PeerTube, then you probably don't want to have a whole container infrastructure just for running your transcodes, because your whole entire thing is probably already running inside someone else's container infrastructure. So it's just kind of like an impedance mismatch in the infrastructure. Like there isn't a good place to plug these things together. So that's why I was starting to think, well, why couldn't transcode containers be more like the kind of sandbox that you have in like a web browser where you can run like a Firefox inside a Docker, for example, because Firefox is not trying to. I mean, maybe it does maybe it supports it, but I think Firefox will not refuse to run if you don't have support for like user namespaces, for example. Whereas Docker, I don't think there's a way to run Docker without user namespaces. I was looking into running gvisor, which is another sort of container runtime in this space. Gvisor is pretty compelling because it seemed to me like something that would be able to provide a high amount of isolation while also not requiring extra privileges, because it's mostly based around a user mode emulation of Linux. Gvisor is basically Google rewrote user mode Linux in Go, like if anybody remembers user mode Linux from the 90s. I actually went through, and this inspired me to try to see if user mode Linux still works, and you can totally still run user mode Linux. In fact, I think I have it on this machine now. I was experimenting with running ffmpeg in user mode Linux, so yeah, this is like Linus's Git tree that I compiled like last week or something, and it's just like make arch equals for user mode, and it'll give you these binaries that just run Linux on Linux. You can give it kernel command line options and whatever, user mode Linux. So this still exists. Unfortunately, most of the documentation for it is about 12 years out of date, since that's about when it stopped being popular. And really, unfortunately for us, it doesn't really at all support multiple processors. It is very uniprocessor right now. Apparently there was a multiprocessor version of user mode Linux, but it was always kind of bad, and at some point, I think like 5 years ago or something, they just removed it entirely. So that was kind of disappointing, but maybe I expected it to be even more decrepit, so I guess it's not terrible. But yeah, I got ffmpeg running in here, but it only runs with one core, which is not great. The goal here, as far as I'm concerned, is to have something that is easy to deploy and also fairly secure by default and isolated enough that you can try to make the transcodes reproducible by giving them the same parameters and the exact same build of ffmpeg. And that's for something else that I want to do that kind of tries to leapfrog what PeerTube can do with storage, and I want to be able to discard video transcodes to save space and then regenerate them later bit identically using the same transcode software and the same transcode parameters. So I think that would help a lot. You'd still need to do the transcode once if you wanted to know what the hash would be, if that's important, which probably would be. So you need to spend the CPU on doing that at first, but then you could reclaim the storage later if it turns out to not be a popular video. After the initial run of popularity, you could discard some of the lower resolution transcodes and then regenerate them in real time if you needed to. Assuming you could probably keep track of like how much CPU it took to generate a particular transcode on your system, and if it is such that you can regenerate it in real time, you can maybe pretty eagerly discard it. So there's a lot more to go into in sandboxes. I kind of went down this rabbit hole really deep and started building my own thing, but for the moment, this rectangle device repository is still using a relatively off-the-shelf configuration of Podman and Run C, or was it C-Run? A couple of very similar container runtimes here. I guess I'm using Run C. Oh, I was trying to get this working with gvisor. Yeah, Run SC is gvisor, but I wasn't sure there was a way to tell this it was gvisor, so I was, I think, lying to Podman and saying that gvisor was actually a copy of Run C to get it to use it. None of that quite works. Yeah, I've got like some work in progress stuff here where I was trying to get it all working inside Docker, but this is not actually useful yet. It builds, but it doesn't actually run the nested container. Anyway, the proof of concept. So we're starting out with this HLS stream, which, just to be clear, is a perfectly fine high-performance video stream that this proof of concept is only making worse. So like, this is not like a useful thing yet. It is a thing that is sort of doing a bad job at being HLS, but in a way that helps me debug a lot of the underlying peer-to-peer components. So if you just take this URL and stick it into ffplay, it should give you a nice fast HLS stream. Like, I put out some food for them this morning, and it looks like they haven't dug in too much, but you can see a few of them chomping around at the edges. It's my pet isopods. These are springtails, but I think that one's an isopod. Anyway, so that's the input. And then we can see a couple of other network resources in here. This is all just, hard-coded for my test setup. This is stuff that you would need to change if you wanted to play around with this on your network. But the most important thing here for this setup here is router, which is, so this is an identifier for an IPFS server. Let's get a terminal we can do IPFS stuff from. So I'm going to run an IPFS daemon locally on this machine just so that we can run IPFS commands locally. We could do things like IPFS ping. This is something that IPFS calls a multi-adder. It sort of looks like a Unix path and sort of works like a Unix path, but the idea is that it can represent any of a wide range of network protocols that you stack together. So you sort of start stacking, you add an IP4 with a particular address, you connect to a specific port, and then once you're on that port, you start speaking libp2p, and the libp2p segment sort of takes a parameter, which is this, just like the same way IP4, this is your IP address, TCP, that's the TCP port, p2p, this is your p2p address, and this is actually a digest of your public key. So everybody on IPFS has a public key, private key pair. Historically, it's been RSA, although they're trying to transition to elliptic curve. And so this is a hash of the public key. Oh, Tuco is visiting. Tuco. Tuco's been pretty chill lately. always good to see the little cat. So this should be an address we can ping. Yeah, it's pretty close by. It is on a different computer on the same network here. So the important fact about this address here is that it is an IPFS server that we can reach from this computer, but that also web browsers can reach. There are other ways this could work, but the path that I was trying to exercise here is that I start receiving video, storing it temporarily in RAM in these IPFS compatible buffer segments. And then immediately those chunks of video are now available to anyone who wants to request those directly out of that RAM store. The problem is I don't expect to have direct network access from the web browser to this the server that I'm about to run, the rectangle device process here. That's for various reasons. Like the most mundane of those is that they just don't speak the same protocol. The web browser wants WebSockets over HTTPS, and so far this only supports TCP, whereas the version of IPFS written in Go, like the main implementation, that supports TCP and UDP and WebSockets. And in this particular case, I've also added a HTTPS WebSocket secure reverse proxy in front of the Go IPFS. So it supports all the protocols, and it knows that it supports all the protocols, importantly. So if I was going to go ask this, or ask the network how to find this, for example, I would get some addresses that are useful to web browsers. So if I grab this hash and IPFS DHT find peer, I think was what we want. Yeah, that's correct. So the DHT is the distributed hash table, which is the large data structure that everyone on IPFS maintains a tiny piece of. One of the things you can ask the distributed hash table for is what addresses do I use to connect to a particular peer. So just based on the public key here of the peer, or the digest of the public key, we can ask the DHT, how do I connect? So you can get this information from multiple places. You can get it from the DHT. If you're already connected to that peer, you can also send it a command called identify, and the identify response will list all the other addresses you can contact it at. So there are various ways this can work. So then we sort of have this path where both the rectangle device process here and a web browser can reach the same IPFS server. And additionally, that IPFS server has a feature enabled where it's willing to route packets with what IPFS calls, or what libp2p calls circuit routing. It can establish a p2p circuit routing through this machine to the rectangle device server. So it does basically act like a router in IPFS land. That's, again, like one way the connection could work. That's how I expect blocks that are just brand new to be delivered. But the other thing that this is trying to do is, as soon as a block arrives and it gets stored in RAM in this IPFS compatible format, it's trying to propagate that block to other IPFS servers. And this is where it gets a little weird and non-standard, because IPFS is not really about pushing data to other servers. It's all about pulling data. Like when you're an IPFS server, you can tell other IPFS servers which data blocks you have, and you can tell other servers which blocks you want. But you can't just send them blocks they don't want, or they'll get discarded. So that's where this other set of parameters comes into play. So in addition to the router, I have this pin gateway here. So this is just an HTTP server. This is also part of the Go IPFS daemon. So this is actually, this gateway here is publicly accessible, but these other IPs are only accessible from inside in case anyone else is trying to play along. If I open this, this is actually just going to be like a regular old IPFS gateway. So for example, you could use this to load the IPFS website. You could also take any other IPFS hash and paste it in there, and it would load using this as a proxy server. So the reason this is useful here is that by requesting a chunk of data through the gateway, you are asking this IPFS server to want that chunk of data. So by just even doing an HTTP head request on here, not even downloading the data, but just asking the gateway to want the data, we can get the gateway to request a copy of it from our IPFS server. So that's actually the trick that I'm using to quickly push data out to IPFS servers. So you could specify as many of these as you want, and it would end up kind of asking all of those servers to request a copy. And then this pinner is similar. This is actually based on a kind of work in progress API that the IPFS folks are working on. Is this it? Okay, so not this Pinata folks. These are like a software as a service provider doing this thing, but the like generic thing here is a web API that you can send an IPFS hash to, and the API will be like, great, I can download that for you, and then it kind of keeps track of that data persistently. I think this is it. Yeah, so they're trying to make a vendor agnostic spec for this. This is very half-baked at the moment, but it seemed like a good thing to try to use for this work in progress, so that's what I'm using. I'm using someone else's implementation of this in Ruby, which I don't really look at the implementation, I'm just running it. It's this one here. So yeah, I'm running a copy of this just to have something that I can use as a pinning service, but it's all pretty experimental at this point. And then finally, I'm using sort of an arbitrary public gateway to provide just actual browser-compatible links to a chunk of HTML that'll actually view the video. So if we put all these pieces together, we should actually be able to get some video through this thing. So yeah, I can go back and tell you what it just did. So this just made sure it was compiled first, and but then it starts up the process. And so this is starting up an IPFS server. It's generating a new key pair. So it's got, yeah, this is calling out to OpenSSL to generate the key. There's our new public key hash. And then it's advertising addresses that we're reachable as. A lot of these are just going to be like internal IPs that make no sense. But this one is actually useful because it's advertising that you can bounce through that public router, well, not public, but like publicly accessible router that I gave it up there. And then establish a p2p circuit connection to this, which happens to be the identity we just generated for this server right there. Hey, Tuco. So we're listening, and then it starts to actually ingest some video. So we're running a container to do this. It's picking a specific version of this ffmpeg Docker image with the specific hash and passing it a bunch of parameters. Hey, Tuco. My intention with these containers is that they don't really need much in the way of I/O. They don't need any file system access. And right now I'm using networking to get the stream in there, but I kind of actually don't want to use ffmpeg's networking support. I think I'd rather use some networking that's somewhat more constrained than that and just use ffmpeg for the actual protocol, like the actual media protocol work. But here in this example, I'm using ffmpeg to get the HLS stream. Oh, Tuco. Tuco's climbing. And then I'm actually using ffmpeg to try to break it into segments. So, and this gets a little weird because I want HLS compatible segments, which means that I want to split preferably right before a keyframe. You can split away from the keyframes, but it's better to split at the keyframe. but crucially, you have to split it in a way that doesn't actually break any of the layers in the media protocol. So you've got to split the MPEG transport stream into two smaller transport streams that are both valid, and you've got to split, the H.264 in a way that, there's like an H.264 parameter block that you have to copy to the beginning of the second half of the stream so that the decoder knows where to start. There's a bunch of little things like that that depend on the format that I would prefer not to have to know about, both because it's complicated and depends a lot on the particular formats. So, it has to change anytime you want to update the format to something more modern. But also because that's where the buggy, terrible code lives, like the code that actually has to deal with the complexities of all these media containers. Like that's the stuff that's likely to have the security bugs in it. So keeping that inside the container and having FFmpeg do as much of that work as possible seemed like a pretty good idea. So right now I'm doing this thing where I try to do the splitting with FFmpeg. If it gives me a block that's over a megabyte, that's a problem though, because for various reasons, IPFS really likes the blocks to have a limited size. I think it's mostly about limiting the amount of memory that IPFS servers need in order to verify content that they've received. So from what I hear, this is a big problem with the BitTorrent protocol. You can create fairly large hashing blocks with BitTorrent that could require a lot of memory to verify from your other peers. Whereas with IPFS, it'll just refuse any blocks that are over a megabyte. And they prefer blocks that are more like, I think, 128K or 256K. So I'm already making blocks that are a little bit chunky for IPFS, but they have a hard limit at 1 megabyte. So I need something to do. So even if, for example, the keyframes here are, every 2 seconds, if one of these happens to go over a megabyte, I've still got to split it. So I've got some code that tries to do that by splitting the MPEG transport stream layer, but it doesn't really know about any of the other media codecs, so it's doing a bad job at splitting the stream. Some players are cool with that, and some players aren't. So it's definitely not a good solution, and that kind of leads into the kind of FFmpeg layer improvements that I'm trying to do. I want to be able to kind of use FFmpeg as a subprocess to not just handle entire media files, but maybe like arbitrary spans of segments, so that you can tune into a stream, for example, that's already ongoing at a resolution that we don't already have a transcode for, and just spin up a new FFmpeg for that resolution. I want that kind of stuff to be possible. But I also think that that kind of infrastructure for kind of defining media transcoding pipelines and spinning them up and feeding data into them continuously, like that kind of infrastructure also seems to be what to use for doing further block splitting. So maybe I have one layer where FFmpeg splits at keyframes based on time, and then I have a second layer where any segments that are still too big go in for secondary splitting, and we have more aggressive options there that split even away from keyframes. Maybe I give it specific frame numbers to split on, that kind of thing. So that was what I was thinking about in terms of transcoding, that something that is still basically using these kind of old school, Unix domain sockets and FFmpeg subprocesses because they work, but trying to be more dynamic in how these pipelines are actually brought up and used, and not have to have everything sort of done once at video import time, like with PeerTube. With PeerTube, it creates a bunch of transcode jobs when the video is first uploaded. If those fail, or if the format changes, or if there's a software upgrade and we're doing the transcodes differently now, like it doesn't know about any of that stuff. You have to take care of all of that manually. So having a system where there isn't just this heavyweight state transition between the video is not done yet and the video is fully done, I would like there to be more gradations there, so the video can be in progress and we can be working on adding additional formats to the video while it's in progress, things like that. So this has been slurping that stream from FFmpeg into RAM, and every so often, I think I have it set for every 5 seconds, it's generating a new playlist for that stream. So the actual blocks they're not changing, we're just like appending to them, but we keep every so often generating a new index that lists all the blocks so far and includes an HTML player that will play the blocks. So you might be able to use this QR code to play the stream right now. I actually ran into a bug on this with some QR code viewers. So if I were to just point my phone, so I've got an Android phone here, if I were to just point the camera app at this QR code, it actually doesn't work. It will cut off the end of the URL. So I'm curious if anybody else hits that too. I don't know if it's like a specific bug that's only in this app or if it's like common for apps to break when QR codes get to a certain length. But QR codes themselves can be significantly longer than this, but I think I'm hitting someone's bug. On the other hand, if I open Firefox, which has a built-in QR code scanner, it actually works great. I just pointed at the QR and it will take a second to load, but there should be bugs in a sec. Yeah, I've got bugs now. You can press play. So, and again, this is going to be strictly worse than just point-to-point HLS, but the idea is that this whole thing is going across a pipeline that you can sort of add additional computers to fairly painlessly. Like at many points in this data pipeline, you can just add additional computers and get more storage without having to really trust the additional computers much. You don't have to trust them at all as far as correctness, and you only have to trust them a little bit as far as reliability. So just to share that with the class, let's open it up on here too. So I think it should, yeah, so I don't have to press play. I think if you press play, it'll still take the same amount of time to load. I think the play button is somewhat inconsequential at this point. But yeah, this is coming entirely over IPFS, whatever that means. I mean, we can talk about what that means, because people who have IPFS hype will probably think that means something impressive, whereas really it's just like we chose a particular set of protocols to make this happen. But I think it's an interesting use case, or I mean, an interesting like proof of concept for this stack of libraries, like an interesting way of exercising them. I can show you what this looks like in the network pane. This also might be a little slow because both the server and the client are running on this computer now, and the server is not very efficient the way it currently is. I think I'm actually just like completely spamming some of my IPFS peers because there is not a rate limit in how much I dial. So I'm probably spending a bunch of CPU and network just dialing peers unnecessarily right now. So yeah, we've got the HTML here is coming from a public gateway here. I'd been using Cloudflare's gateway a lot, but this is a different gateway. This is the one at ipfs.dweb.link, which I think is run by the IPFS folks. So this is a pretty simple little file. Oh, it's interesting that it's rendering it there. Mostly this bit of HTML exists to include the hashes for the rest of the content. So a very simple video player. It's loading a script bundle also over IPFS from the public IPFS gateway. So like what this actually means is that we're making a regular old HTTPS request to this server, which happens to be running a copy of the IPFS server, which it uses to get the content based on its hash. So it's just a web server, right? It's just that we're using IPFS as a way to name the contents, and we're using some of these public gateways as an entry point. Could easily be using any other way of serving HTML. This just seemed like an interesting thing to try for the proof of concept. So then we've got a link to the actual video. And this is another IPFS hash that refers to a subdirectory within all of this that has the HLS data. And these are ugly because they're URL encoded, but these are actually just libp2p multi-addresses that indicate which IPFS servers to connect to first. So this is the same router server that is accessible over both WebSockets and TCP. But in this case, we've, again, this is like kind of a mess, but this is the WebSocket URL, the WebSocket multi-address for the same server. So got the HTML, got the JavaScript. Yeah, this is just like 2 megabytes of JavaScript. And then we've got some WebSockets. I don't actually know why there are 2 WebSocket connections here. I think that's probably pretty arbitrary. And then we can see that data is happening, but we can't really see much of what's going on here because this is mostly encrypted. So yeah, we don't even have the beginning of this, but this started out with an unencrypted multi-stream protocol negotiation, but then all of this is encrypted using, I believe this is encrypted using a protocol called Noise, which I don't know much about. So you can see a bit more looking at the actual console output. A bunch of this output is from hls.js, which is it's the one reading the chunks of MPEG transport stream and trying to assemble them back into a single video. So you might also notice if you reload this that it probably reloads quite fast because all of this data gets stored in a IndexedDB cache by default by the JavaScript IPFS library. Should be able to like seek around. Obviously, this is not as fast as it probably should be. And there's a lot of debugging that I need to do just to see where are the problems currently. Like right now, I just don't have a great view into where all the particular slownesses are in the system. I kind of continue getting it to this point where it's like worked better than it ever has, and it keeps being kind of like a strenuous proof of concept for these components, but you know, it still needs some work before it's quite as smooth as plain old HLS. So this is still going, it's still serving out those blocks. If I grab a more recent URL, then the beginning of that will be the same, but it'll have new video at the end. Oh, cool! We got a report that it's working fine on iPadOS. Nice. Yeah, I haven't been testing this super consistently on iOS, but I tested it once or twice. And there's a question about the chat room that I was using other than Gitter, the one on Big Blue Button. I still have the server running for that, but I don't actually have the room for that up right now. Yeah, I don't know. I feel like that was a nice experiment, but I don't know how much I feel like using that on like every single stream. But it's been a nice way to have like audio, video, call-in kind of stuff when we want to do that format. I'm just not sure it's super compelling for text. Someone else mentioned Matrix, and I probably should actually set up a Matrix server for all this. But I know a lot of developments happened on that since we started this whole streaming nonsense, and it's probably a lot more usable nowadays. I fed the isopods, but the food is probably still cold, and they're not that interested in it. So, this is basically what the proof of concept does. It just takes video in, stores it in RAM, and like wastes a lot of CPU to do it. It's pretty much the thing. You can see a bit more of what's going on, though, actually looking at the files it's creating on IPFS. And again, like, file is sort of a weird word for this, because this all exists in RAM in the server here. I don't even think I mentioned that this is written in Rust. I probably mentioned that I was doing Rust, but this is all written in Rust, and it's using the Rust libp2p implementation, which is fairly new, but pretty neat. There are a lot of the bits and pieces you would need to make a fully Rust IPFS server, even if there isn't quite such a thing out there. And so I used a lot of those libraries. So in RAM, it's got these things which are compatible with IPFS files. They don't usually exist as files on disk, but if I wanted to, I could download them. So if I grab just the hash portion of that, it is a valid IPFS identifier. Let's just make some room in here. So this is asking the local IPFS server on this computer to download the files from the Rust IPFS server, which happens to be on the same computer, but they're still communicating to each other just using normal peer-to-peer networking the same way they would if they were distant. I could also try grabbing this file from a different computer. I think I can log into here. Yeah. This is a different computer that also has an IPFS daemon on it. And this one actually seems to have an easier time finding it. Yeah, the performance of IPFS can vary a lot depending on the specific path that the data is taking to you. So it can be a little perplexing sometimes, because sometimes it can seem really fast, and sometimes it seems like it's just stopped for no reason at all. Like very broadly, it's pretty fast at getting data from point to point when the two peers are already connected. But if the connection needs to be established, and even more so if it needs to figure out where the peer is, it can take a while to just like bounce around the DHT looking for the right address to find the content. And it would be great if there were more tools for debugging that sort of thing. Like, I don't think there is an easy tool for just noting, like, I mean, I can ask it, for example, like DHT, which peers actually have this content, or what peer has this particular block. You can ask questions about individual pieces of data, but I think part of why this is complicated is that when we ask for one hash here, that just quickly blows up into, probably hundreds or thousands of hashes, because each directory hash has a bunch of references to files in that directory, and then each file has usually a bunch of blocks inside it. So very quickly, this IPFS client does some round trips resolving those reference lists, and then ends up with this very large list of block references that it's all interested in. And then it kind of becomes a bit more like BitTorrent, where you just want like a bunch of things. You don't super care what order they come in. And then as a user, you're mostly just seeing a progress bar like this. Whereas under the hood, there's actually a lot more stuff going on with data kind of coming in irregularly from different places. All right, so this is one of those. So the outer directory here, it's mostly just like a wrapper around the actual video that provides a browser-compatible experience. The video directory in here is just the HLS content. So index.m3u8 and then a bunch of mbeg transport stream files that are all under a megabyte because this video was easy. Let's try something that's not so easy though, and let's try a 4K video maybe. Because it doesn't have to be 4K, just like most things that are a little higher resolution than that will occasionally end up with blocks over a megabyte, but let's just do something that will definitely need larger blocks. So let's copy most of this, except I don't need the non-default interval. 5 seconds is actually kind of fast. And this separates the parameters from the rectangle device itself with the parameters for FFmpeg. And let's just grab some video from diode zone, because that's easy. See, that should have come up. Search on PeerTube definitely needs some work. Oh, that's interesting. I wonder, so I recently turned off support for WebTorrent files, leaving only HLS, which is probably what broke this, but I didn't expect that to break all the downloads. I wonder if it's only broken some of the downloads. I wonder if it only broke the downloads that are over 4K. Let's try another random Tuco video. Yep. Interesting. That is super inconvenient. I wonder if it's a logged out versus logged in thing. I don't actually have a convenient login on this browser. Well, there are other ways we can get that content. It's like hard to find searching for Tuco, but searching for 4K, I find it. Copy the video URL. I guess that's convenient. I didn't realize that was there. That is not the right video URL. We could just take a whole side track to debug this PeerTube issue, but maybe not. This is what I wanted. This is supposed to be in the download box. And we do not want to try to transcode that in real time because my computer will just fall over. Yeah. So now it is doing its fallback approach where, so it's getting these segments from FFmpeg that are often way too big. So these are coming from FFmpeg. They're like 2.5 megs and 1.2 megs and whatever. And then it's splitting them at the first MPEG TS packet boundary it can find that is still below that 1 megabyte boundary. So I think a lot of players are going to be unhappy with this, but some players are cool with it. I forget what Firefox and HLS.js think about it.
Why are some players unhappy with it?
Oh, it's totally non-standard. Like, you're supposed to be able to decode video from the beginning of any HLS segment, but in this case, it's like slightly broken and they have to backtrack to the segment before it before they can really decode anything successfully. Oh, where is this breaking? I feel like this is breaking trying to get the HTML. Get a fresh tab. Do I have middle paste? Gosh, I miss middle paste. I don't have that set up. Maybe the gateway is being slow suddenly. We could switch gateways. The default gateway is actually Cloudflare if I just leave that off. I figure Cloudflare deserves to be a default gateway. Again, like, I mean, all this stuff is only necessary for the way that this particular demo was set up. You could serve the player off of anything that serves HTML. This should generate a player after like 30 seconds. Yeah, I was always getting impatient waiting for the first player URL. There it is. Interesting. Oh. This is a bit random, but I'm going to try killing the IPFS server that's on the same machine. I can't tell if I'm just imagining this, but I thought I'd had connection problems with other IPFS servers trying to get to this IPFS server when there are two servers advertising on the same IP address. Like, they should be separate because they have different public keys, but I think that might be a bug in Go IPFS somewhere. If I reload this, does it work? Oh, I'm being rate limited now. Great. What? That's not what I wanted either. I don't think HLS.js is going to like this at all. But maybe it will. Oh, it's failing to get the script because we're rate limited. I should just switch to the other gateway. Oh, yeah. I should, speaking of rate limiting, I should rate limit this. It's trying to import this video as fast as possible, which also might be causing some bugs to show up. I should rate limit this to real time. So one thing I've been trying to do with this experiment is work on a video like ingest pipeline that would work equally well for like pre-recorded video and live video. So if you're doing live video, you can import it as it's happening, and you can stream the video out from the video server directly, but you'll also just have a copy in your video library as soon as the stream is ended. But then also you could run the whole pipeline faster than real time when you just want to import videos. Oh. That was pubgw.
Someone's asking about the cargo drop command.
Cargo drop. Oh, thanks for the $5. Concrete. Cargo drop. I'm missing where that was. Is that in Gitter?
YouTube. It's Matthias.
Yeah, sorry, I'm behind on chat. I'm catching up a little bit. There's a question about whether the web server is relaying the IPFS, or does it simply relay the IPFS to the user's browser? I'm not quite sure about the question, but the role here of the IPFS server that I'm using as the like intermediate node between the browser and this program, it's mostly for that peer-to-peer circuit feature. So I'm kind of doing these two things. I'm using the peer-to-peer circuit to have a way of tunneling through that server to get to this server to get blocks directly out of RAM. But I'm also trying to push a copy of the blocks to that server so that after a short amount of time, those blocks exist in both servers, and there's another path for the client to use to get them faster. But the client is actually like the web browser is actually speaking IPFS to the IPFS server. Like it's using IPFS over WebSockets right now, and there's a whole protocol stack that you can kind of add and remove pieces of like Legos, but it's basically the same pieces that exist in the Go implementation of IPFS, just arranged a little differently to work in a browser. Oh, cargo drop command. I don't know what you mean by drop, but so cargo is a package manager and build tool for Rust. We should definitely talk about Rust in more detail because it's just a fun language. Yeah, right. Live streaming, building live streaming. That is kind of what I've been into lately. Is trying to run the video site more than just trying to make video. All right. Yeah, I don't know if this is gonna. Oh, that's right. I was forgetting where we were stuck. So we were stuck on changing gateways, which I think they did actually. So yeah, I feel like there's a bunch of places we could go and kind of trying to make this, kind of pushing this demo a little further and trying to figure out like what pieces of this architecture are worth using. I feel like I'm not quite satisfied at the proofiness of the proof of concept until I see it doing real-time transcodes. So I was hoping to at least get a little further on the transcoding part of this experiment before making like long-term decisions about architecture. Okay, so I don't know if that's actually gonna... Oh, it is! Amazing. Do we have audio? My mouse is super sticky, but yeah. Yeah, I think it's going to have a bunch of remuxing errors because HLS.js is not properly reassembling this video because I'm giving it bad segments. So, yeah. This is like working slightly better than I expected it to. This is also 4K video, which this computer probably would always have a little bit of trouble playing with this little CPU free. We could switch to a different computer for playback that has more CPU free if that seems to really be the bottleneck, but let's just try downloading these files and playing it with a offline player. Alright, so I killed the local IPFS server that we had here. I'm just going to use the IPFS client on this other computer. Same kind of structure. So I think most of these videos have a keyframe every 2 seconds. So ideally you would see this splitting every 2 seconds, but pretty much all of these ended up in 2 pieces instead of 1. If the timestamp tracking is correct, I think those pairs should all add up to 2, but I'm not sure they all do because I don't think the time tracking is perfect. So each of these files should be a valid MPEG transport stream, but I think if we start looking at them in any deeper detail, they'll start to look very bad. So this first one starts out with a header that you'll actually see at the beginning of all the FFmpeg output. I don't actually remember what kind of packet this is, but it's, it's identifying the encoder and the X264 options. So there's a couple of human readable fields that you can find at the very beginning of the stream. Then, most of it just looks like noise. So I think this packet with mostly Fs is the program association table, which MPEG TS uses to assign, I think, like a 16-bit number to each audio and video stream. So my code is actually replicating that at the beginning of each chunk, but that's as far as it's getting. Oh, and it knows how to split. It knows how to split on a boundary between MPEG TS packets. It won't cut a packet in half, but that's about as good as it gets. I'm going to copy this to the local machine because I can't play video from this SSH. Oh, or I could just SSHFS. Nah. I do not like, I'm still not used to just like how much everything is made of hashes in IPFS land, but that's not really IPFS's fault. That's just content addressed storage, which I still feel like content addressed storage is mostly just like, it's got to be a scam somehow. But I don't know. I think that's just the part of me talking that doesn't like having to rely on hatch collisions for my data integrity, but practically speaking, it's fine. Oh, is this it? Yeah. Oh, right. So ffprobe, I was trying to use this to see where our keyframes are. This is a little complicated because we have audio packets and video packets that are both mixed together. Oh, there's an option for ffprobe to get just the video packets. Select streams, I think. I think I just want stream 0. Okay. So those are all the video frames. And now I just want the keyframe flag. Use TR to cut off the new lines. I remember coming across some trick to cut off all the new lines, but now it's escaping me. Oh, if someone's asking what the heck the long folder name is, It's a base 32 encoded SHA-256 hash, the best kind of file name. Oh, -D. Gee, I thought I just tried TR and that didn't actually work. I guess TR wants the two strings to be the same length. Oh, that's what D was for delete. All right. Anyway, keyframe flags. So there's our first chunk. The second one won't even decode because we don't know what codec it is. And like, where does that codec come from? There's probably some packet that I'm leaving out of the MPEG-TS split that I'm doing haphazardly. And then the next segment starts with a keyframe again. So I've probably just like broken every other segment with this bad split that I did. That one's fine. That one not so much. Yeah. And then if you just concatenate them back together, I think they work fine, which is what some players end up doing because they just buffer all the MPEG-TS and then they just play it continuously. So if the player does that, then I think it won't notice how bad a mistake or how badly I've messed up the stream here. Let's try that. So just for verification here, if we do Z01, that's one of these that just did not decode. If we do Z00, we get a certain number of frames. Let's see if we concatenate both of those, we get slightly more frames. Yeah, that looks like one more frame. So, not a convenient place to split the segment, huh? All right, so this is like one thing I've been fussing with is video technology that tries out different peer-to-peer approaches. And I still, there's a lot that there's a lot of pieces of IPFS that you might not want to use in a video server, but it seems like the very core of it where you're addressing blocks of data with hashes, and there are some protocols you can use to exchange those blocks of data. That seems pretty well built and pretty applicable for this. That's a good question. GTS is wondering how I've been learning Rust, and what I would recommend for learning Rust. I mean, I think that depends maybe more on your learning style than on the particular language. I've always had a hard time learning programming languages unless there's a project I can dig into with them. So, I mean, I still feel like I'm learning Rust. I'm certainly not an expert in it, but the projects that I've been doing in Rust have all been like helping me learn it in different ways or different aspects of it. But I've only done a couple of Rust projects at this point. I've done, the biggest Rust project was probably the stuff I was working on for Tuco Flyer, the camera robot at the other studio last year. But really, I mean, this project and the one that I'm about to show you are kind of my two best Rust learning experiences so far. So I feel like I'm still an apprentice at this, and I keep finding better learning experiences as I dig deeper into these projects. So yeah, that directory name is an encoded version of a hash of its entire contents. Just like this directory name. This hash is just another name for the video directory in the same directory. right, so I got kind of distracted by the sandbox part of this problem because I wanted a way to run these sort of reproducible FFmpeg transcodes in a way that has some security isolation and a completely self-contained file system. And ideally, I just want this to be a library that you can just drop in some Rust code. You don't have to compile. I mean, you don't have to like set up a whole pile of operating system dependencies first, but you can just compile some Rust code and use it without having to like be a system administrator, without having to have a like a native machine. I would want it to work really well on containers and virtual machines. So this is set up to use Podman, which has been all right, but like Podman itself is just one layer in this stack. It's kind of analogous to the Docker command line, and it manages the file system storage for all the images that you download, all the layers in those images. And it has some interesting support for doing that file system, either using Linux kernel support with a union file system, or it can kind of do it all in user space. I think just using hard links and directories. It has just like a simulated virtual file system in user space, which doesn't require privileges to use mount or set up like a union file system on the machine. So that seems useful for making a transcode container that's easy to deploy. So that gets you part of the way there, but the container runtime itself, there are a couple of options for that. The ones I know about are runc, crun, and gvisor, all of which are kind of designed for Docker but would run with Podman too, or Kubernetes, and like anything with the OCI container specification. Yeah, so I tried a few things. crun, so let's see, runc is if I remember correctly, the normal one, the like standard reference implementation in Go. And then I could be getting these two backwards, but then crun is the one written in C, which is a version of runc, but written in C instead of Go. That's its main feature. I think it is slightly interesting to use that one sometimes because there was some feature that they had that seemed to make it more likely to support unprivileged Docker containers. Like I think it was possible to turn something off that you couldn't turn off on the other one. But I've just been trying to find like a combination of pieces that I can run inside of like ideally an unprivileged Docker container. I don't want to have to add more privileges to a thing in order to have locked down transcoding inside it. I don't want to have to give the unprivileged media server access to privileged container infrastructure just to get it to sandbox the FFmpeg. So what I would really like is just a sandbox you can just drop in wherever. So I was looking at gvisor to see if it could be something like that. Gvisor is an interesting project. It is annoying that it's a Google thing, but it's nice that they released it at least. So my understanding of gvisor is that it was the internal project that they had been developing for a long time for the product that was known for a while as Google Compute Engine, I think. They were running Python and other pretty unconstrained workloads on it. And they wanted it to be a fairly like serious security sandbox so that they could run completely untrusted, potentially malicious customer workloads on their internal infrastructure safely. And that was what drove the original development. So because of that, it's a heavily multi-layered sandbox. At its heart, it's a user space emulation of Linux, much like user mode Linux. It's basically user mode Linux written in Go. But it also has a bunch of additional pieces. If it was just user mode Linux written in Go, it would probably fit my guideline or fit my my needs pretty well because you could just run it pretty much anywhere. But it's also really built to have additional layers based on operating system namespacing, based on seccomp, for like system call filtering. So just out of the box, gvisor doesn't really run in an unprivileged Docker. It requires a bit of additional privilege. So I looked into that some more. I tried hacking around on it a little bit, but then I kept getting the impression that they were trying to solve a problem which is fundamentally way more complicated than the problem I need to solve for multimedia transcodes. I don't need like a very general purpose implementation of Linux. I don't need networking. I need very limited storage. I pretty much just need a way to run processes that link against a standard C library and run x86 instructions on Linux. Like, there's not a whole lot of I/O that you need to do video transcoding. There's a whole additional can of worms you could open for hardware transcoding, but I think there's a viable path toward that. There's already some options for doing hardware transcoding inside Docker. So one option is maybe I have my own like tiny simple sandbox for like easy installation, like most of the use cases people have. But then if you want to do hardware transcodes inside containers, maybe there's a different like system that you install for that. Or maybe it's actually not too hard to pass through like the dev NVIDIA or whatever to the sandbox. Obviously that's a security liability, like having your containers access the GPU, but it's probably worth it for a lot of folks, especially if it's on a machine that doesn't have other trusted workloads on it. So anyway, gvisor is pretty interesting. I definitely want to keep an eye on it and keep maybe trying to integrate it in. I was even complaining a little bit on Twitter about about my attempts to trying to get it to run outside of or in an unprivileged sandbox, and one of the gvisor developers took the liberty of opening a GitHub issue because of this. Here it is. Yeah, so this was a weird interaction. Like, I didn't really intend to do this, but I was talking about this on Twitter, and this guy opened the issue, which seems somewhat helpful. So I explained what I was trying to do here. I was like, I've been investigating approaches to add containers in sort of already low privilege environments that don't add a portability burden. And this guy tells me a whole bunch of stuff I already knew and asks me to read a blog post I've already read, which is probably helpful. But then this comes along, and I had already been like tinkering around with my own sandbox for a few days at this point, but this guy comes along with a proof of concept patch that just like rips out portions of gvisor to get it to run without special privileges. So I do want to look closer at this and try it out. So this is still using the user space kernel written in Go. So it's still basically the user mode Linux kind of thing with its own namespace for, not like a kernel namespace, but its own like actually separate implementation of like process IDs and signals and stuff like that. That's pretty interesting. I don't know how this interacts with their file system support. Just back on the theme of gvisor being kind of more complicated than what I needed or what I wanted, though. Like, gvisor is actually multiple separate pieces that are all kind of wrapped up into something that looks like a single binary that implements that OCI container runtime. It's got sort of the outer layer that implements that like runsc command line interface, but then it's got the actual user mode kernel, which they call the sentry, and they run that in a fairly locked down environment that doesn't have I think they use seccomp for that mostly, but also namespaces, and it has very restricted system call access and has to do pretty much everything through a connection to a different process. They implemented that connection using the Plan 9 file system protocol, which is an interesting choice. Seems like something that like Go and Google folks would do. It's kind of funny. And they have this process that they call the Gopher, which is basically a Plan 9 file server that does privileged things on behalf of the unprivileged process. So that all sounds pretty good. It's mostly just that if I want to run this in a library environment, I actually want a Gopher that is not doing anything to the real file system, but is using like a virtual file system, and I'd want probably a library that can do the sort of outer setup layer of this rather than a separate binary, that kind of thing. But yeah, I mean, something to think about. There's probably a way to hack on this and turn it into something which is easy to deploy. But it also kind of leaves me wondering, like, oh, do I do that? Or do I just start on something that's simple and go from simple to slightly less simple rather than trying to cut out just the pieces of a complicated thing that I need? So that's what led me to this other project that I just threw on the internet a few days ago because I thought I might want to work on it on this stream. And it's a sandbox called Bandsocks. And I wanted to make something that was like really more inspired by how browsers work, where you don't have a sysadmin setting up separate user ID groups. You don't have the ability to make separate mounts. You really just have to do everything within a couple of processes with features like setcomp and pipes to communicate between the processes, that kind of thing. So I started just trying to build something like that in Rust. I figured it would be an interesting Rust project, and a lot of the pieces that I think I need seem to at least be like partially in existence. Like for example, there were already some Rust libraries to communicate with the Docker registry. That's what this thing is. And yeah, so I just started building a thing. I tried to make some decisions early that would limit the complexity. So I really don't even want to try to make this a complete implementation of Linux. I mostly just want it to be able to run things like FFmpeg and like media transcodes of various kinds. I don't really want it to have complete file system support. I mostly want it to be running Docker images out of a RAM disk, and probably no networking at all. So it'll be largely a system call filter, but I think it might still technically have to be kind of in that blurry space between a system call filter and a user mode kernel. I think it'll still end up having to basically be an elf loader, for example. I don't think there's any way for me to firewall off the file system parts of the kernel while still using the real kernel's elf loader, so that's going to be a little bit annoying. But other things like, I think file descriptors are real file descriptors. I don't think I necessarily need to virtualize those. So, for example, the read and write syscalls and other file descriptor related things might just be pass-throughs. Those are my current thoughts on this. This all might evolve. It doesn't make for that much of a demo right now, but it does some things. Let me clear the cache just so that it's a little more honest. Okay, this is already compiled. So I keep saying this is going to be a library, and the thing that I just built is not a library, but it's just a command line driver that is trying to be just a minimal exercise of the library. So I've got a command line interface. Why am I opening this in less? I can give you syntax highlighting, I'm sorry. So I'm using the popular Rust command line argument parser library called CLAP, which stands for Command Line Argument Parser. I think Atom is bogging down and I might need to kill it and restart it. Do I give up on Atom and go back to Emacs? I think Atom has trouble with very large directories open, and I had some of those. Yeah, so I've got a command line interface defined in this YAML file. And mostly it's just doing this. So I've got this container object. I want something that's really high level. Like if anybody's familiar with Rust and the standard library, there's a standard library function or object for a subprocess, like a command that you can run. I would like running a container to be just as simple as running a subprocess. So I was trying to kind of model it off of that. Yeah, standard process command. So the idea behind this is it follows the builder pattern. So you call this constructor command new, and it gives you a mutable command object, which you can call all these builder style methods on, and they'll just add some additional settings, you know, in this case, adding some arguments to the argument list. And then kind of extending that, you can call the output method on that built command, and it'll actually both run the command and collect the output of the command and return the output. So it gives you this way of kind of chaining together pieces to do fairly high level or low level things without having to have like a single function call with a bazillion parameters, or without having to have like some other data structure you have to fill in. It's a way of just kind of incrementally modifying the state of some object that you have an API for. So I took kind of the same approach here. First, so this is also asynchronous. So some of these awaits are waiting for asynchronous operations to finish. So this image reference is just like a parsed representation of a Docker image name version string thing, which we're pulling, adding some arguments to, and then running. And it's basically just like running a subprocess. That was what I was trying to go for. So a little bit of that works. Have a little bit of options here. Let's try running Alpine Linux. So it's downloading from the registry, and now it's done exactly what I expected it to. So yeah, we can look at the data that it downloaded in the cache, but the registry has mostly JSON files and tar files. When you ask for a Docker image by name from the registry, it's giving you a manifest which has information about the individual layers and information about the config file and naming them all by their SHA hash. And then you can go and download those individual blocks of data. It's kind of funny that like IPFS and Docker both use content addressed storage. So some people have already thought like, oh, what if we just combine those? And I've seen some experimental like Docker over IPFS storage bridges. But right now it's just a happy coincidence that we're using one content address storage thing to build another content address storage thing. And so all this is doing up here is downloading and decompressing the tar files. It's decompressing the tar.gz into tar, but it's not actually blowing up the tar archives onto the local file system. Once we're down to flat tar files, after that point, everything's virtual. So we've got some just like flat files here in home cache bandsocks, which this will be OS specific, but on Linux by default it's here. All of this whole project is fairly Linux specific anyway, so I don't know why it even matters. So it's got a temp download directory, it's got a manifest which has those. So yeah, that's like the full expanded name of the Alpine image that we got. And that's just crunched up JSON, which we could probably make nicer. So, and then using the generic content addressed storage, we grab the config and we grab the layers, and those end up in this other cache directory. So, and if we check the file types, we should see tar and gzip. Yeah, POSIX tar archive. So once we're at this point, there might be multiple of these for images with multiple layers. In this case, there's only one layer, but if we tried to download something like Ubuntu, we'd probably see a bunch of layers. part of me really wants to add a progress bar for this, but then part of me is like, oh, it's a library that runs on the server. Most of the users will not need a progress bar, but it would be nice to have one in the API anyway. Because, I mean, the Ubuntu image is a little big. I don't know if we're actually going to wait for that to download. Anyway, once we're at this point where we have this tar archive just sitting there, after we've cached that, anytime you start this up, and like if you ran Ubuntu again, oh, I guess that download actually failed. Did the server hang up in the middle of our download, or did I do something wrong, I wonder? Let's come back to the big image and maybe just try the smaller images for a minute. Oh, I need the full name of that FFmpeg image, huh? I really need my middle paste back. Oh. There is actually... These URLs are a little bit weird. Docker.io is a bit of a lie right there. The server for that is actually something like registry1.docker.io, but all the official Docker stuff has a special case for docker.io. This is downloading the FFmpeg image that I probably will actually want to use. It's like 25 megs. Okay, so the second time I run that, this should be a lot faster. Yeah, so now it runs pretty much instantly. So every time I run it this time, it's not downloading any of the files, but it is actually reading the metadata in those tar files. So it memory maps the tar, reads the metadata, and then constructs an in-memory file system, and then uses that in-memory file system to locate the entry point. And that's approximately where we're at. Like, we can resolve file names, we can locate the entry point. I've got just like an ELF binary blob in memory that we're ready to run. And now I'm starting to set up the actual runtime environment. So I need a way to have some boundary between the inside of the sandbox and the outside of the sandbox. The way I'm doing that here is with ptrace, which is a kernel facility that's usually used for implementing debuggers like GDB or LLDB. The idea with ptrace is that you can have a tracer process, which is usually like a debugger, which attaches to some other collection of processes, like one or more processes. And the tracer has the ability to kind of start and stop that other process, to trap system calls. ptrace can interoperate with seccomp, secure computing, which is the system call filter facility that a lot of things use that want sandboxes, like web browsers would use them. Docker uses it. So we can use seccomp to restrict a bunch of the system calls. We can use ptrace to trap them and get an opportunity to run different code when those system calls would have been invoked. We still need just like a place to stand to run all of this code. Like, we need just like, where does any of this live? So there has to be some place that is relatively privileged, that has access to the data that you're actually trying to process. There has to be some good place to run the actual tracer, and then there has to be some good place to run the code that you're tracing. So a lot of what I've been doing on the sandbox so far is like setting up those environments. And the idea is that the environment outside the tracer, which is roughly analogous to in the gvisor world, that would be like their Gopher process. which is their Gopher is still really locked down. That would be one difference between this architecture and gvisor, is that the sort of runtime communication layer that you'd be talking to, which is more privileged, would be basically part of the application that the sandbox is embedded into. So it would be, for example, in the media server, it would be probably like an in-memory stream of media data, like in RAM, coming directly from the other components of the server. It wouldn't have to be something that even exists in the proper like kernel space file system. And then I'd be relying more on the separation between that sort of outside privileged process and something which is inside the sandbox or on the boundary of the sandbox and is more privileged. So I'm thinking that looks like a Unix domain socket that you pass into the sandbox and then use that for inter-process communication. So I've been setting that up. And then the tracer itself, it seems like it really should not be in the same execution context as the application proper. So, and this is something that's maybe kind of like a fuzzy boundary, but like it really seems like ptrace as a kernel API doesn't know anything about multi-threading. It is a process-oriented API. So I think a lot of this gets really, really hard if I start wanting the tracer to ever have to interact with threads. So the architecture that seems to make a lot of sense to me at this point is to have the tracer run in a fairly isolated environment. So basically a process that has a lot of seccomp restrictions, that doesn't rely on any external binaries, so statically linked, which has a very limited set of system calls because we need something that's that we can really lock down with seccomp. Probably a single process so that we don't have to worry about the interactions between multi-threading and ptrace. So this starts to look like something where you fork off a separate program, you probably exec and just like close all the resources you can, lock it down as much as possible. And then from that other exec process, you set up your ptrace jail, like you start setting up an environment where you can run emulated system calls, and either only emulated system calls or emulated system calls with some very small punch throughs, things like read and write and break maybe. BRK, the one that's used for allocating memory. So that's kind of what I've got set up. I've got a process that is written in Rust, but a fairly low-level flavor of Rust. So I'm not using the standard library. I'm making system calls directly. I'm not allocating memory. And this is all so that I can operate on this level that's below where the standard C library would normally operate, and just above the kernel. And once I'm there, I can act as a bootloader to sort of set up another subprocess with even lower privileges using seccomp, and with the ptrace active. And from in there, probably emulate the exec by loading the elf image and jumping to the entry point of a new process. So that's like kind of the sketch I've got in my mind for how this works, and I've got pieces of that built. So that low-level ptracer process, I've got a lot of the stuff for that in place. That's what's called sand in this architecture, because it's the thing that goes inside the sandbox. It's the first thing you put in the sandbox is the sand. And then the runtime is the higher privileged loader for all of that. So that's what's involved in talking to the Docker registry, setting up the virtual file system, and it'll be kind of the bridge between the application code and the lower level code. And then let's see, the rest of this is just the command line interface. Runtime right now, so the file system directory, like a lot of the code here is for that file system emulation piece. It's just like, you might have heard me talking about nested cargo builds on Twitter. This is what that's for. It has to build the sand as a separate project, pretty much, using different settings and even a different version of the compiler. And then it just wants like a fully finished binary of that once it starts compiling the runtime. So it includes that in here. So then a bunch of stuff was happening and a bunch of stuff was breaking. So I mentioned I started to set up an inter-process communication system. So the runtime has an IPC server. It's got, it sets up a Unix domain socket pair, and it passes one member of that pair into the child process. So the sand process starts up with an environment variable that points to the other file descriptor. So that's how they get a communication channel to talk to each other. The sand process really quickly uses seccomp to turn off a bunch of system calls, so it can't open additional sockets, it can't open additional files, but it can send and receive messages on file descriptors it already has. So using that file descriptor that it gets through the parent, through an environment variable, the sand process can start talking. So I'm just trying to do like a quick back and forth here to like just send and receive messages. I think the first actual IPC tasks that I'll be doing to get a process running are things like implementing mmap so that I can write an elf loader. To load an elf, I need to start mapping sections of virtual files from the virtual file system into memory. So I've already got those mapped into memory in the runtime, the higher privileged process. I just want a copy of that in the lower privileged process. So I think the way that works is that I use the IPC to ask for access, and then the runtime has to verify that the access should be granted, and then send a copy of the right file descriptor to confer access to the resource. And this gets hairy quick. One of the things that I'm going to need to use this IPC for in pretty short order is mapping the memory of the process that I'm running in the sandbox. So the tracer, I can trap system calls already. So that's actually what's happening right here. This syscall info those are the parameters from a system call I'm trapping. That's already happening. That's not hard to do with ptrace. But in this case, it was an access system call, which is used to check whether you have access rights to a particular file by path. So we have to emulate this because it's about the file system. We don't want to pass it through to the real file system. This has to be about the fake file system. But we also don't have enough information to do that yet. We don't actually have the file path because the file path is that's the file path, but that's a pointer to memory in user space. So we need to map the memory. Normally, the way you'd map that memory is there's actually a couple ways to do this now. ptrace itself does give you a way to access memory in the process that you're tracing, but it's really inefficient. It's 4 bytes per system call. Nobody wants 4 bytes per system call. That's terrible. So you could do it, but it'd be like sucking data through a cocktail straw. It'd be terrible. It's like only something you do if you have to. So the other options, there are some fancier, newer kernel features, like I forget what it's called, but there's a system call you can actually use that is not ptrace. It requires the same privileges as ptrace, but it lets you just copy data directly between two user space processes. When you start getting into esoteric system calls, though, that's where this starts being like a portability hazard. If I want to run this on random unprivileged Docker containers people have out there, those random unprivileged Docker containers already have their own security policies that I have to fit inside of. I think it's pretty easy to find here. think this is actually it. I was looking for an article that links to it, but I think this is the right file. So this is basically the same stuff that we're doing with setcomp. It's just this is at a higher level. This is, I think, using libsetcomp and like a Go wrapper around that, whereas I've been using the kernel interfaces directly to reduce dependencies, and so that I don't need to be using libsetcomp from inside the sandbox when I don't even have dynamic linking working yet. That's the other thing, is the first couple of hurdles in getting this to work are not going to be anything application specific, but just running a binary or like running the dynamic linker. Like the dynamic linker is the first application that needs to be run in user space, right? Like as long as you're not running only static binaries, like the container that I downloaded has an FFmpeg in it, but it also has an LDSO in it, and I need to run that LDSO in order to run its libc and everything else. So this is the kind of project that will teach you a lot about the internals of how user space and kernel space in Linux collaborate. This is also a pretty big list. So these are all the system calls that I think are just like flat out allowed. Yeah, with no exceptions. You can just do all these things in Docker. So it's like a lot of stuff you'd expect. I mean, Docker does not rely on setcomp to namespace any of these resources. So like system calls in Docker that deal with the file system are fine because Docker is using a different kernel feature to namespace the entire file system. And I'm trying to deal without that. You know, I'm trying to make something that will work without those kernel features because those kernel features are not available inside of Docker by default. And allowing that inside of Docker is kind of a security risk that I don't want to have to ask people to take just to make the transcodes more secure, you know? So yeah, a lot of these are pretty straightforward. I think there were some interesting nuggets in here, like they restrict ptrace for older kernels, I think, to work around a specific security bug. Yeah, I don't know what happened before 4.8, but somebody must have fixed a serious bug in 4.8 here. And there's some interesting system calls in here, but if you try to use something really modern, it's probably not going to be in here. Oh, there's a cool system call I wanted to use. Is this it? p2p open. Yeah, these are new as of last year, so I can't rely on these being around. Like, they probably aren't even going to be in most of the headers that folks are using to write their setcomp profiles. But, like, there's a way that you can open a file descriptor that refers durably to a process ID, solving the age-old problem of you have a process ID, the process dies, you're not the process's child reaper, so the zombie goes away, and now nobody's told you that the process ID no longer means the same thing, and you've got a security hole because you're sending stuff to a process that's not the process you think it is. So, like, that's been an age-old problem that we only have, like, 99% mitigations for. There isn't really a good mitigation for that. And then, oh, somebody came up with a way of turning a PID into a file descriptor, which is great, but it's too new. Can't use it yet. So there's stuff like that. And I think there's something along those lines you can use to do that. I'm trying to remember what that system call I was thinking of that lets you send data between processes. It might be too new for this list too. memfd create is pretty cool, and I think I can use that. Let's double check. Yeah, okay, good. Yeah, no, I do want memfd create. I'm already using that. So that's a way to create anonymous files that just only exist in RAM. And It's extra tricky, but you can execute these by execing the node in /proc/fd. It's crazy, but it's super useful. So that's actually how I'm bootstrapping the sand process right now. So yeah, we're just like, where is this going? So we're so back on IPC. I've got the IPC server running in the runtime process, and I've just been debugging, just like getting the data going both directions. I've got this. Let's see. I think the sand process is sending this no-op12 and then no-op34 to the runtime, and the runtime's receiving it, and then the runtime is replying it with this no-op in the other direction. And that's approximately where it's breaking. So these receive message debug lines are from me trying to debug the receive message side of that. -11 here is E again, so it's just saying there's no data available. But then right here, receive message is receiving 2 bytes, which is actually both of these no-ops because they're each 1 byte. And then this is where my current bug is. I don't know why this is still 0. I'm supposed to be buffering those 2 bytes, but my buffer is disappearing somewhere. Yeah, this is really just trying to boot up. This was trying to run a shell or something, like a generic subprocess. It's not actually loading the binary it's supposed to load yet, but I'm just trying to go through the steps of like, how can I get something running inside the tracer? That's kind of where I'm at with the sandbox. Oh yeah, Mr. Radar draws the comparison between process IDs and handles on Windows. Handles and file descriptors on Windows. Yeah, no, handles and file descriptors are basically the same object, just like the Windows and Linux flavor. And yeah, Windows did a much better job at using handles consistently right off the bat and avoided a lot of these kind of like ancient Unix problems. Whereas like Linux did not invent this. This is just like them following in the footsteps of like problems that have existed since the beginning of Unix, and then maybe some of them will eventually have good workarounds. In practice, it's not extremely concerning because Linux is careful to only reuse process IDs extremely rarely. They only reuse process IDs once they wrap around, and the namespace is quite large. So in practice, it's probably not terrible, but I would still like a better solution. And I guess where that comes in for my program here is if I want to be, so again, going back to the tracer trying to get access to the memory behind one of these arguments. So if I want to know what file it's calling access on, I need to read that string. The string is just an unknown sized object that's just sitting in user space memory somewhere. So I need probably a way of mapping pages of memory. The normal way of doing that, if you're a debugger and you don't want to use the cocktail straw, one word at a time ptrace approach, is you open the proc mem node in the proc file system. So if you're a debugger and you have some other process that you want to access, as the same user, you can access that file. Usually you can just memory map that other process's entire address space or some portion of its address space. You can even get a list of individual mappings nowadays. I don't know how new this is, but so if you look at proc self, that'll be whatever the current process is, in this case the shell that I'm running. But if you had a specific process, you could always look at its process ID in proc. And then, so let's just try self. So I was talking about mem. This looks like it's 0 size, but actually it's just a file that represents the entire memory address space of the process. If you started reading or writing it at offset 0, that would be like reading or writing a null pointer, so not super useful. But if you mmap, or if you mmap a specific offset in there, or if you read at a particular offset, then it's just like you're reading at that address in that process. So it's great for debuggers. So you can just map that. Then I think it's map files. Yeah, this is even better, right? I mean, maybe sometimes you just want the whole thing, but a lot of times if you're a debugger or some other weird kind of program like that, you kind of want to know what memory goes where. And so, like, there is a file maps, which just lists this all out. So this is just a list of addresses, permissions. I always forget what this column is. It looks like it should be size, but I don't think it is. Oh, this is the offset in the file. So yeah, this is indicating that these are chunks of memory that were mapped from the actual less binary. So now that I'm using less to view this file, proc self refers to less, whereas proc self was the shell before. But in this case, we're kind of introspecting the less binary. So these are all the individual segments which are mapped out of the ELF. So if we were replicating the loader behavior, we'd be reading the headers on this binary and noticing that it's got these chunks of memory that have these permissions and setting up these memory maps, starting at an arbitrary location for address space layout randomization. Of course, we're not running less directly usually. We're running the dynamic linker, which is this down here. And the dynamic linker itself is actually what's loading the rest of these libraries into the address space. So I don't know what this is off the top of my head. I'm guessing thread info. And then that's the standard library. And then we've got some cute little bits down here. We've got the stack. I think what is vvar? I think that's the kernel variable segment. I think that is a thing that is used as part of the VDSO. The VDSO is interesting. That is a fake shared library that the kernel itself provides that gets mapped into any process that wants it and implements some of the system calls in a library. It's basically just used for time. It's used for like stuff like get time of day. What else? Maybe nanosleep, but I think mostly get time of day. It's like, there's this whole infrastructure and it's used for different things on different platforms, but like the main thing that people use VDSOs for is to check what time it is without having to make a system call. Because on most architectures, you can just check what time it is by asking the CPU directly. You might need some information to translate that into the right format, but you don't need to like switch into a completely different address space and ask a privileged process to tell you to read its watch for you usually. So this is a huge performance improvement for processes that read the time frequently. So that's why the VDSO is a thing. I don't know if I'm going to have to implement the VDSO. I certainly might. Depends on whether I can get away without it. Because like I'm fine with not having FFmpeg actually know what time it is, but if there's something that crashes without it, I might have to implement it. And then I forget what vsyscall is. I think that's related to the VDSO, but I think that might be like the entry points that the VDSO uses, but I'm not really sure. These are some suspiciously high addresses, right? Like you want to be able to call them with small negative numbers. Well, thanks for the kind words, everybody. Glad some folks are finding this interesting. Well, yeah, I mean, I can certainly, like, answer specific questions or kind of just, like, ramble about this. I might just kind of try to hack on it and see if I can get it working. Trying to remember specifically what I was doing. So IPC is definitely the general thing I was working on. There's the IPC server in the runtime, and the IPC client in the sand. The sand code is all pretty weird because it's so like, this has been an interesting way to get two very different views of Rust. Since the runtime is all written in pretty high level Rust code that's like, it's using asynchronous IO and HTTP and just all the fancy libraries I want to really without it being a total mess. And then the sand, I wanted to avoid using even the C standard library because it's possible that maybe we can make it work, but my impression at this point in the development is that the sand process will be much easier to work on if it uses a very well-defined set of system calls and does not rely on any libraries. And I found myself needing so many low-level pieces of Linux anyway, like, needing to make system calls for setcomp and like, needing the full-strength version of read message, stuff like that doesn't really, most libraries won't give you anyway, so either you have to find a library that is just like boutique for that purpose, or you just go directly to the kernel for what you need. So yeah, I'm trying to do the thing where you pass file descriptors across a Unix domain socket in order to confer capabilities to another process. And that's like a slightly esoteric corner of Linux, so a lot of libraries don't support that natively. But I did find an interesting add-on library for the Tokyo asynchronous I/O framework that is common in Rust anyway. Somebody made a nice add-on for its Unix domain socket support to support that file descriptor passing functionality. So yeah, the code outside the sandbox might actually look kind of nice in that respect. Oh, I should probably just start at the main program. Well, so we saw the main for the entire program, which is down here, that mostly creates this container instance and then goes from there. Container.spawn is pretty interesting. So again, this tries to be a lot like the command builder kind of pattern. So a lot of this is keeping track of what parameters you want, like which command line arguments, what environment. Some of this is not used yet. Oh, right. So spawn is what turns the container builder into a container. So the container is a running container. The file system here is basically like a tempfs. It is in memory only, but it tries to be very Unix-like with like real inodes and everything. So yeah, vec option arc inode is the basic type here. This means that the inodes, which are basically like a file or directory or something, like a node of stuff that lives in the file system, they're all numbered in a flat array. They're also all individually reference counted, which is that's like not a normal inode thing. That's more of like a virtual file system feature. That's so that you can make shallow copies of an entire file system cheaply, which seems like a useful thing to be able to do for the containers. So I'm already using that to kind of shallow clone the container image to use for the kind of running container file system. And that just involves duplicating this array, but not duplicating the actual inodes, just referencing them again. I don't know why my syntax highlighting is breaking right here. I think that's a bug in the Atom plugin. So yeah, I can resolve paths in the virtual file system. I can get file data, resolve symlinks. This stuff really needs test cases. A lot of this I was just kind of hacking to see if I can get it working, but it needs a lot of like orderly tests. I do have a debug formatter that prints out the file system in a reasonable format though, like a ls-l basically. So yeah, the VFS itself, the file system, most of this is focused on reading the file system. So it's got stuff like get inode, resolve symlinks, resolve path segment, get file data. Get file data specifically, this does not return just like a regular slice. It's actually returning a reference counted section of a section of a reference counted memory map. So it should be pretty efficient for just having, like one memory map per tar file basically, and then just like a bunch of little reference counted pieces of that floating around. So most of this is read. For writing the file system, there's a separate VFS writer that you attach that takes a mutable reference to the file system. And that's actually responsible for stuff like inode allocation, building directories, handling reference counts. Oh yeah, this is kind of confusing. I need a better name for this. The inodes are reference counted using Rust's atomic reference count type, the ARC. But then I also have like an explicit reference count, which is the like POSIX stat reference count, like the one that increments when you have a hard link. So it's sort of like I've got the real like visible reference counts and then the like implementation specific reference counts. Yeah, I definitely think Rust is making systems programming fun again. Yeah, I mean, I feel like part of why I've been doing this project is just like it's useful to have a bit of a mental health boost around like doing something with technology that I don't completely hate, and Rust is at least a bit of that for me. Like it's nice to have a project that feels, you know, like it's got a whole surrounding of technology and people that might be like not entirely gaslighting me. And yeah, I like Rust. I'm still pretty hermity and don't actually know a lot of Rust people, but they seem great from what I've seen so far. So the sand process itself, its main is a bit weird because it is a no standard library program. So, what is even going on here? The actual entry point isn't even here. This main is like, I'm trying to make this look like a normal main, but the actual entry point is over here in libc start main, which is like packaging up the arguments in the environment slightly before calling our real kind of nicer looking main and then explicitly exiting. So this has very little boilerplate. Like we've got a binary, we've got like somebody making an ELF file for us, and we've got, you know, the Rust core library, which is certainly helpful. We've got startup.s, which is calling libc start main and taking references to all these for no reason. So we do have startup.s, but pretty much nothing else. Like there's no libc. I guess startup.s is probably technically part of the C compiler standard library. Not the C standard library, but like would be libgcc if we were using libgcc. I think it might still be called libgcc, but this is all using LLVM. So yeah, this file is kind of like just support routines for stuff that you would expect to be part of your standard library, but we're not using a standard library. So writing to the console by calling a syscall with no buffering, calling exit specifically, installing a panic handler, that kind of thing. But then once we actually start getting into the real main, this is running in a very weird environment. So this sand binary is really small. It's like 150K, smaller than that actually. And it actually just gets fully embedded inside of the runtime library. So when you, as a Rust program, instantiate one of these containers using the runtime library, it's just taking this little chunk of binary data that it's already got handy and sticking it into an isolated memfd, one of those memory files, and then using that trick of execing procfd to run it. And actually, I didn't implement this code myself in the runtime. I've been doing some low-level stuff that's similar on the sand side, but there's this. Oh, Tuco's about to knock my laptop off the table. Oh, thanks. That's not going to have network now, but it's all right.
Is that okay?
Yeah, that's fine. It just won't be especially useful, but at least Tuco won't be knocking it off the table. I'm going to open up the chat on a different screen so I can still see it. Too many rectangle devices. Yeah. Oh, I just noticed a good question from Jarrett, who's asking if having a housemate has made Tuco easier to socially satisfy. Maybe. I mean, Tuco seems to like the extra company. Um, I think Tuco and I have just been going through a bunch of things, trying to figure out what works. Some of the housework that I did earlier this year was adding extra doors so that I could, have some separation between Tuco and the outside world, but then also like make it easier for him to, um, to be like, I don't know. Cats are weird, right? Like sometimes Tuco really wants to be on the other side of a door, like he has to be on the other side of it. But sometimes he actually seems to really like having a restricted space. So having the right set of doors seemed to help him a lot, and figuring out when he likes to be in what size of space. So one thing we've been doing recently actually is when he's getting ready for when we're both getting ready for sleep or whatever, when I'm getting ready for bed and Tuco is getting ready to be a cat at night, which doesn't involve entirely sleeping but involves some amount of sleeping. He seems to chill out a lot actually if I bring all of his stuff into our bedroom and just close the door. It feels like having less space helps him feel like the spot is more under control sometimes. Oh, now Tuco's chewing on wires. Gosh. He is chewing on the wire from my headphones right now, which I'm not extremely concerned about. Tuco. Okay, I might have missed some stuff in the chat, but I've got the chat back. Oh, I have the Twitch chat back. YouTube is being weird. Gosh, you'd think that being on your channel page on YouTube while the stream is ongoing, it would just take you right to the stream. Okay. Chewing the wires of the headphone. Oh, I mean, if he was chewing on the cable itself, I would be more concerned, but it's actually already got a couple of layers of protection, so I don't even know why he finds it appealing. Tuco's just weird. Right, I think Tuco does like, Jarrett suggests that maybe Tuco's seeing me playing with wires and he wants to play with wires too. Yeah, he does get like that sometimes. Should I keep this from falling asleep then? Aww. From Twitch chat, Kanishiwa says that their cat just headbutts their shins for like 30 minutes till he falls asleep. That's pretty cute. All right. System calls galore. Oh yeah, I was going to talk about that cool library, and then I got distracted by Tuco. Tuco is all over the place now. Gotta get him back on camera. Oh, no, Tuco, that's fiber optic. No. Gosh, if Tuco messes up that fiber optic, I have a giant problem. Oh, 2K. What a cat. Yeah, I've got this fiber optic cable that runs all the way from the front of the house to the garage. And I don't have tools to splice fiber optic. I just have to avoid breaking the cables. So if he breaks one of those, it's super annoying. I probably have to either rent a splicer or redo that entire cable run. Cats are pretty great. Tuco is a really nice cat. He's a great friend. Anyway, I found this great library. I'm curious what else this is being used for, because it's just such a strange piece of code. It's called Pentacle. It executes programs as sealed anonymous files. That's like all it does, but it's great. So you can use it like this, and it'll just like re-exec the current program from one of these memfds, which, I mean, that seems like it would indicate the use case here. Like there's probably some kind of like crypto operation happening where you want to make sure that the program has a specific binary and then you verify it or something like that. That might be what this is used for. I don't know. The sealed aspect means that no one can read or write that memory after it's been sealed, which seems to be like it would be useful for security if you wanted to validate the program somehow, like checking a signature. It also seems like it might be useful if, well, actually, I think something in here said, yeah, so actually this says it's useful for executing programs that execute untrusted programs with root permissions, which is like, that's quite a trip, right? So you want to execute untrusted code with root, probably with some other lockdowns applied, but it'll have access to this file descriptor, presumably, so you want to make sure that it can't overwrite some of the more trusted parts of this code. So yeah, it's pretty interesting. I'm curious what this is actually used for. I found it useful because it was a convenient way of creating an anonymous file from just like a raw chunk of ELF data. I'm not sure I care about the sealed aspect of it, but it seems like a handy additional bit of security in case someone manages to get a hold of the file descriptor. So that's pretty cool. So I'm actually just using this from the runtime up here. Oh, container startup. Oh yeah, I actually moved that to the IPC server. The IPC server is currently responsible for actually starting the container binary. This is a little bit weird. I might change that. So yeah, this sealed command is from that pentacle crate we were just looking at. This sand bin, this is just like the raw ELF data that's like the 150K ELF file or whatever. And so we're copying it into a memfd and running it with a very specific set of arguments and environment. And this is how we pass the 1/2 of that socket pair, this socket pair. So yeah, this is just the IPC server basically setting up the child process in a way that they can talk to each other. And then I think that debug output we were seeing is coming mostly from these, the send message and handle message, which has the little like arrow message things. Tuco, what are you doing? Tuco is really making sure my wires are all cat-proofed. He's checking for problems. I certainly made my peace with writing unsafe Rust on this project. I don't think I'd written any unsafe Rust working on the Tuco Flyer project, but there's unsafe code all over this one. It's not that bad. It's basically just like writing C code. Oh, checking for Cat6 cables. Yeah. Oh, yeah, there's a question about what the goal is for the stream. This is a pretty good time for a recap. So I was mostly just going over some pieces of kind of half-baked Rust code I'd been hacking on with the goal of building some infrastructure for live decentralizable video streaming. So this is all kind of related to the thing that I'm doing on an ongoing basis, which is running a video site. I suppose I should mention that if people don't know about it. If you go to diode.zone, you can add videos to a place that is not YouTube and is maybe more friendly for the stuff that you are creating yourself. You can read the detailed rules at the about, but it's basically designed to be a place for content that you've created. So it's trying not to be like a archive of like random Creative Commons stuff, but more like a place for people to upload stuff that they've made collaboratively or on their own. So I kind of seeded it with a bunch of my own electronic stuff. There's some other electronics folks on it, like Blitzity DIY, who I was showing off earlier. There's some more like kind of gamery stuff here. Folks sharing like game streams, some like pet videos. So, kind of a random set of things. A lot of these that are blurred are game videos, I think. I don't know why they're set as adult content. Or okay, this is keyboard hacking. Yeah, so I run the server for this, and I'm interested in both the technology that allows people to create communities like this and just like trying to understand the practical aspects of making a nice place for people to share video and like what that's like and where it breaks and where it's good, that kind of thing. So PeerTube is an interesting site. Like I definitely recommend folks play with it if they're interested in decentralized video or decentralizable video. Like the strongest aspects of it are that it's a content management system for video that is mostly ActivityPub compatible. So you can upload videos and you can have your instance link up to other instances and share video metadata. The vision for PeerTube is that it also is more of a peer-to-peer network system. Like it has ability to share bandwidth between servers, and if a bunch of people are watching the same video, that all those peers can contribute to the hosting of that video, things like that. And that's been a bit more, just like more pie in the sky, like stuff that like, things that like should be theoretically possible but never get tested, up to things that like just, aren't really there yet. So, Tuco is chewing on a short Cat6 cable carrying USB data. Do you like that, honey? That's the keyboard and mouse for my workstation. So yeah, I'm trying to investigate what kinds of maybe better technical pieces would help with the storage and peer-to-peer distribution of video for something like PeerTube. So, been interested recently in kind of... Been interested lately in like trying to make a thing that is maybe more fun to hack on and feels more worth extending than PeerTube, but is still like not an extreme departure from PeerTube. Because it's a great piece of software as it is, but it has a bunch of rough edges and it has a bunch of things that I don't particularly necessarily want to improve when I could rewrite them. So it seems like it would be useful to have a, like just another implementation of something that is PeerTube-like, just like we have, like Mastodon and GNU Social and Pleroma, and we have various sites that work with ActivityPub. And I think that's helped, at least on the like microblogging side, to keep folks honest with the protocol and to help with interoperability. And I don't really see anything like that with PeerTube yet. There's there's just PeerTube and different versions of PeerTube, and even between different versions of PeerTube, the compatibility isn't always great. So I feel like having an additional site that PeerTube could interoperate with would be better for interoperability just in general. And then I think that there's some stuff that I can just do better with like video storage. And I have a friend who's also been interested in this, and we've been talking about this together a lot. And they've been interested in the kind of user experience and web client side of it. And it seems like on both the front end and the back end, there's maybe a lot of room to make something which is not an extreme departure from PeerTube, but is maybe like our take on it, and something that is maybe easier to hack on or more satisfying, or something that is, I'm really hoping to make something that supports like storing and distributing large video archives a bit better, because I feel like I keep running into the limitations of PeerTube in dealing with my like 5 terabyte collection of video on Diode Zone. It's one of the larger PeerTube servers out there by storage space, at least. So that's kind of what this is. And then the specific pieces that I've got kind of up on the screen, or at least I had before I got Tuco in my arms. I was working on a kind of proof of concept IPFS based streaming server called Rectangle Device, and then kind of a proof of concept sandbox piece that I was developing to maybe use inside that. And that's this BandSox project, which was kind of me attempting to make like an embeddable sandbox that you can just link as a library in a different program pretty easily. Don't interrupt Tuco when he's doing a comparison study on the chewability of different data cables. I should show you all the data he's collected so far. I have an entire cable recycling bin full of data. I guess I told you what I'm working on, but I didn't really tell you what the goal is for the stream, since I don't necessarily have a concrete goal. There isn't really a milestone I'm expecting to get to, because it feels like most of this is going to be like on background information, but maybe we'll make some progress on the development too. I want to get Tuco on the camera, but he's been walking around too much for me to do that safely right now. Really, if only we had a robot for tracking the cat around the shop. Somebody should get on that. I'm not actually doing the file descriptor sending over the pipe yet, but the reason I'm using this like full strength send message with the full message header and whatever is that's how you get access to sending file descriptors in POSIX. This is like a header that can describe one or more buffers of data and then one or more buffers of control stuff. And the one or more buffers of data in this case is my one buffer of bytes up here, but the control buffers, which aren't here yet, those could include messages like, here's a file descriptor, which is, it's a lot more involved than just like sending the number across the pipe, right? Like what's actually going on is that the kernel is duplicating a resource, which is referred to with a file descriptor, and the process you're sending a message to gets a copy of that resource, and then the corresponding control message will then indicate what file descriptor number that resource has been mapped to. But it's the actual conferring of the resource across process boundaries that we're really interested in here. Yeah, I don't know what was going on here. So I think the case I was debugging before streaming this is returning 2. This should be setting receive end to 2, and this should be 0 and 2. but instead it's 0 and 0, and I don't know why. Goal equals hangout. Yeah, basically. Really the goal is I need to get better at doing this regularly, because that's what I'm kind of trying to do and I suck at it. I was doing the streams pretty regularly when I had a consistent project and an uncomplicated motivation structure around that project. And I think in some ways the uncomplicated motivation structure was a bit of a lie, and having a project that's a bit more thought through feels good. But yeah, it feels like I could be doing these kinds of streams pretty regularly if I get my ducks in an order and people actually want it. I'm trying to remember whether this seg fault was intentional or not. I think I expect that because I am faking the mmap and the mmap is returning a bad pointer. I think that's why this is seg faulting, but that's not actually what I'm worried about. It's these are bad. It's dropping that message on the floor right there. And this feels fundamental enough that either I'm doing something really low level and bad, or I'm just like misunderstanding Rust. So E again should be a constant, like -11. I kind of want to just try splitting up this match and the assignment into separate steps in case that gives me some other information. Pretty weird though. Oops. No. I occasionally try to use keyboard shortcuts from an editor that is not the editor I'm currently using. I'm just laughing at Jared again. Their cat is currently staring into their soul because his cat wants the soup. Tuco, when he wants some food, he can be extremely intense. That's just weird. What are we doing here? I'm wondering if this is me misunderstanding how to write match expressions in Rust. Like maybe it's treating E again as a variable here instead of as a constant. Like if I move this, it should have the same effect because this match guard is checking for, okay, is len even signed? Yeah, that should be I size. So that should have the same effect, assuming this is not a bug. But if it is a bug, maybe that's actually going to catch it red-handed. Oh, yeah. Huh. Oh, huh. Yeah, I don't think that actually exists in the scope. I think it was supposed to be ABI : E again, but why wasn't, like, I think the only reason this is compiling is that Rust is treating this as an identifier, and then we're just not using the identifier, so maybe this was getting lost in some of my other warnings. Because I do have some other warnings I've been ignoring because they're just like code that isn't complete. I mean, I don't think any of that's related. I think this is just a problem because this is, like, this thing that I'm trying to match is not a type, it is a value. So I think putting it here in the match expression is just not even legal. I think doing that would be a little better. Let's just change that too. That feels like a foot gun. Like, I would have expected Rust to tell me that that value is not being used. But maybe I'm still misunderstanding what's going on. Now I'm receiving my nops. Yeah, that fixes the receive message. I think the next thing I was trying to get working here was sig.io. So right here, I'm just polling receive message before every ptrace event poll. So let's talk about main loops. So like, I don't know, if you're used to writing event-driven code, you're probably used to having a way to attach like a callback or a handler to an event or something, so that, you know, you read some data, and then when the read finishes, you get a function call or your promise resolves or something. And at the very kernel of that, like, well, not kernel, that term's overloaded at this point, but at the very center of that abstraction is some kind of system call, usually, that waits for a number of things at the same time and returns as soon as any of those things happen. So the classic way of doing this is poll or epoll or select. Select is the vintage way of doing this, and epoll is the modern way of doing it on Linux. The basic idea here is that you're creating a kernel space representation somehow of a set of events that might happen, and then getting woken up when one of those events does in fact happen. And select is kind of full of inefficiencies and limitations, whereas epoll is designed to do something much more reasonable, but they're both fundamentally doing the same thing. Where this gets complicated is that even though most things in Unix are a file descriptor, and you can wait on them like this, because select and epoll are for waiting on file descriptors, not everything is a file descriptor. And if you have one of those, then you have an incompatibility, and you have to wait on that thing using a different kind of waiting. Or you have to find a way to convert that thing into a file descriptor. So that's one of the reasons why that system call I was ogling earlier, that pid-fd open, was pretty interesting, because that lets you take a process ID and create a file descriptor, which lets you do things like this. It lets you wait on that file descriptor, and that gives you the same effect as waiting on the PID. So, because that's what we're doing in the ptracer. The ptracer is waiting for events, really, right? Like, it's event-driven. The events are mostly system calls that are happening inside the tracer. In fact, I can show you exactly this loop. So main comes in here. Right after tracer.spawn, we've got tracer.handle events, which is the main event loop here. Tracer, not ptrace. So yeah, this is just an infinite loop. This is the thing that I just patched in there to do the IPC receive, but ignore that for a minute. The main thing that this is doing is calling this wait ID system call, which is a slightly generalized thing for waiting on process IDs or a couple of other kinds of IDs. but not file descriptors, just IDs, like process IDs. Oh, Tuco is looking for a wire to chomp. I think I've done a good job covering all those wires, but he's gonna make me nervous. Tuco, are you gonna bite the microphone antenna? Tuco. Always getting into trouble. This feels like a common problem in operating systems. It's like there are different categories of things you can wait on, and you end up kind of separating your workloads based on which kinds of objects you can wait on the same thread for. So you might have like one thread that's doing all your file descriptor based events, and one thread that's doing all your process ID based events or whatever. Mac OS has this problem too. I mean, maybe not anymore. I think there's a way now that you can convert mock messages into file descriptors, but for a long time in Mac OS, if you wanted to wait on a file descriptor and a mock port, you had to do that on separate threads. So I used to work on a program that used both mock ports and file descriptors for I/O, and it was designed to assume there was just one event loop for everything. So we had to do the classic thing where you have like a proxy thread that wakes up for the mock messages and then sends a message through a pipe to wake up your other thread. Not especially great for performance, but it works. That's a good question. Do I happen to have an allow for that warning in the crate root? I don't think so. I don't think I have any allows in my crate root. I think the only warning allow I've got in here is a dead code for ABI. Because I've got a bunch of stuff in here that I put in here because I was using it for a minute, but then I stopped using it. But I don't want to delete it from here because I'll probably use it again soon. So I put allow dead code to silence those warnings. The proper way to do this is to have unit tests for it all, and so it's not actually dead code. But I'm not at that point yet with this project. And this is mostly just stuff that is, like, this is the definition of a bunch of types. Like, the way you would unit test this is to check the definitions against, like, the C version of the code, I guess. But the way I would probably actually do the unit tests is more just, like, functional testing on the system calls that these represent, mostly. So yeah, I'm kind of having that problem with the multiple kinds of things I'm waiting on, because this tracer, which I'm still hoping to keep to a single thread. I don't want to deal with multi-threaded ptrace because that just seems like a bad idea. I want to have a single thread which is handling ptrace events, handling IPC responses, and doing those things like one at a time. Like, I want basically a single threaded event reactor. I don't expect this to be a performance bottleneck, really, because like this is not going to be in the data path for the most part. This is going to be dealing with opening resources for the most part. So there'll be a lot of activity back and forth between the sandbox and the runtime when something is loaded, and some more activity when files are opened. But then just like reading data from a file continuously, I don't expect much back and forth. So I'm much more interested in keeping the binaries small and simple and the attack surfaces small and simple, rather than trying to optimize for like the fewest context switches at this level of the stack, because this whole thing is like set up basically. So I was gonna try to use asynchronous I/O to solve this problem. This is a Unix feature that is not very popular. I don't know if it's like an original POSIX thing. It feels like a very old part of Unix that maybe used to be a better idea, but is now usually a really bad idea. So the way this works is that you set some flags on a file descriptor. There's one I'm missing. I know I'm missing actually. That is the process ID of the process you're delivering a signal to. You set that. You set like the async flag, and now when a file descriptor is ready to read, presumably ready to write too, although I don't actually know if that's true. I know at least if it's ready for read, you can get it to send you a signal, like a Unix signal. And for anybody who's not familiar with Unix signals, it's sort of like the Unix user space equivalent of an interrupt handler. Like the kernel, as it's doing normal process or normal task switching, like on the way back from a system call or whatever, it'll just notice like, oh, you've got a pending signal / interrupt for this process. Let me deliver it for you. And it'll just inject it into your stack as it generates like the return from system call or whatever. So they can happen at like any time, and they generally can't just make arbitrary calls into libc because most of the standard library is not required to be reentrant. Yeah, so like what this means is the kernel can call your signal while libc is still happening. So like you do like a printf or something, hello world. If a signal comes in right there, you could be inside the printf, and now your own function is running, and now it wants to printf, and now printf is now forced to be reentrant, which it usually isn't. So signal handlers are annoying. This is why people usually don't use them. Usually you would use threads, or you'd use... usually you just have everything be a file descriptor and use epoll. But in this case, I have processes and file descriptors and no threads, and I think I want to use asynchronous I/O. So the tricky part about this is that your I/O notification comes in on a signal, and there's not a lot that you can do safely in a signal because it just comes in pretty arbitrarily, like an interrupt handler would. But the useful thing here is I don't even especially need the signal handler to do much. I really just need it to interrupt my other wait system call. So like, if I was just waiting on the process ID forever and some IPC data was there, but I didn't know it, and that's what I was actually waiting on, there'd be a deadlock. But if I'm waiting on that process ID, so if my process is blocked on the wait ID system call, and I'm waiting on the system, or I'm waiting on the process ID in that sense, but algorithmically, if I'm actually waiting on an IPC message, unless I have a way of blocking the process on either the IPC message or the process ID, then I'm going to have a deadlock. So if I can interrupt the system call, if I can interrupt that wait ID with a signal, I don't even care if the signal handler really runs, as long as I can use that as an opportunity to check for an incoming message. So I could see a few different ways that this could work. I could basically just like ignore the signal handler and just like poll after every wait ID. I think the most sophisticated way to use asynchronous like signal I/O involves there's a way that you can get some additional parameters with your signal, and one of those parameters you can set up as the file descriptor of whatever event woke you up. I think this also still gets more complicated though, because classical signals do not have a way of keeping multiple signals pending. It's just like a bit field. Every bit is just set until the signal finishes and it's cleared. But I don't really know anything about this, but just from like skimming kernel source code and trying to figure out like what even exists related to this, it does look like there's a way to queue asynchronous I/O events in signals if you're using real-time signals, which I still don't even really understand. It's like a new class of signals in Linux. I think the main distinction is that they're queued, like fully queued instead of just put in a set, and that the ID numbers can be larger than the max that would normally fit in a sig set. But other than that, I don't really know what's going on there. So we might try that. I'm tempted to just keep this as simple as possible, though. So I don't fully have the SIG.io stuff set up right now. I took a bit of a detour just to get signal handling itself working, because handling signals without a libc is not extremely straightforward. So I wrote a quick signal handler thing in this no libc crate or no libc module that I've been putting together. That's what this is. So we have to set up the sig action structure. If you start building code like this, you'll also start to realize that there is just such a mess going on in the interface definition between the libc and the kernel. Like if you look through headers, there'll be a bunch of things called sig action, and most of those are not what you're looking for. There's like a different version of sig action from glibc's perspective and from the kernel's perspective. And then I think there's also like there's like an internal version of the structure in the kernel and a user-facing version of the structure in the kernel, and those are all in the headers. So you have to know which of those to look for. And I've often found it to be helpful to just like compile a C program with the data types that you're looking at and use that C program to do a size of or attach a debugger to it and like do some address calculations just to make sure that the data types you have are the data types you want. So I definitely ran into that with this sig action. This is pretty architecture specific. I mean, it's specific to Linux on x86 64. Different Linux architectures would need potentially a different layout here, although I think generally the structures themselves are defined in cross-platform headers. It's just that the different platforms usually have different sizes for some of these objects and maybe different alignment. So like handler and restorer are architecture pointers. So I think these are like, void stars or usize or whatever. So 64 bits on 64-bit architecture. I think flags is always 32-bit. And then I think mask is a long array, so it's 64-bit on 64-bit platforms and 32-bit on 32-bit platforms. I don't really care about 32-bit Linux right now, though. Like, I'm happy to the extent that this project runs anything to try to like pare that down to the bare minimum. Like, if it'll run 64-bit FFmpeg, I'll be pretty happy. I think I just want to finish setting up this asynchronous I/O. And I can probably take out some of this excessive debugging now. Tending to keep in that first receive message debug. Just for the next stage where I'm actually trying to... The SIG.io stuff is going to all be about like when am I calling receive message rather than what it returns. Oh, that's a good question. Yeah, that's a great question. Mine Trizzle on Twitch is asking if I can specify something like a critical section, like you could on ARM, to avoid the signal interrupting you in the middle of like a libc call. Yes, it is usually prohibitively expensive to do that because you have to issue a system call to turn on the signal and then issue another system call to turn off the signal. I feel like I've seen software that works like this, but it's not really something you want to do generally because just all the extra system call overhead is a real drag. Emacs, yeah. Gosh, yeah, I don't know how to feel about editors for the longest time. Like I used to be like actually a fan of Emacs. Like I liked it as an editor. And I feel like nowadays I feel kind of past being a fan of any editor. Like there are just editors that I use, but I don't know if I'm like a fan of any in particular. Like I feel like Atom is kind of cozy, but is like often overheating my computer. Um, I used to use Sublime Text a bunch. I've kind of given that up for Atom just because I feel weird about just like always demoing a piece of commercial software basically. And I still like Emacs. I still actually use that a lot on the terminal. And I still use Vim when I don't know why I use both Vim and Emacs. I think I'm just weird. I think I used to use Vim because I was tired of waiting for Emacs to load, but modern computers load Emacs pretty fast. Nano. Yeah, I still use Nano sometimes too. Okay, so receive. So this is sending, oh, where do we send the NOPs? It'd actually be useful just to see that again. Oh, there it is. Tracer. Hi there, RPC server. Yeah, so that's completely debuggy right now. So I'm sending these from sand while we're initializing the tracer. And then the reply should come from this one. Yeah, so this is just printing out the incoming message and then sending a generic no-op back. The messages themselves are all defined in this file over here. So these are, this is, if you haven't come across this, this is, I don't know, like one of my favorite features in Rust. I mean, I guess it's sort of a Rust feature and sort of a library ecosystem feature. So Rust has a very nice macro system for doing work at compile time. In systems programming especially, there's just a lot of times when you want to set up something kind of elaborate, but you don't necessarily want it to happen at runtime. Like you want to do all of the work ahead of time and do all the work at compile time. So it could be initializing a data structure, it could be like, hashing something or converting an image to the right format or whatever. There's a lot of examples of this. One case that, so like, I don't know, Rust just takes this to a pretty interesting place, and like they use macros for everything from like formatting of like printf strings. So when you see like a print line or a format in Rust code, that format string is actually being parsed at compile time. And so yeah, like this thing. This bang at the end of print line actually means that this is macro. So syscall is also macro. There are some different kinds of macros. There are some macros that look like functions. There are macros that kind of look like decorators for objects or for crates. But like it's very common to see sort of these function-like macros, and these can just do arbitrary things to the Rust abstract syntax tree. So they're quite powerful. In this case, the macro is actually parsing this format string, and it's basically generating some code that does a write of this string and then converts this argument into a string, and then that's it. If you had more stuff in here, it would generate more pieces of code. But it's actually much nicer, I think, than the like sort of printf style formatting that C has, and it's a good example of, I think, where the simplicity of C is like, it is simple, but that's like often the only thing it is. Like you don't actually want that behavior in C at runtime or at compile time. Like at compile time, you want there to be more validation, and at runtime, you want there to be just like less string processing going on. So it's like the only reason C is like that is because it's convenient to implement using the tooling available. And I think Rust formatting is a big step up. But then you can go even further. Like, so serialization is super nice. This derive, these are all derive macros. So these are ways that some existing code that's built into Rust or part of a library that I've used will run on this type. So in this case, it's enum. It could be a struct, and it'll generate some code that goes along with that type. So debug is actually generating some code that adds a debug formatting trait to this. So that's when I'm doing that format like question mark colon thing, that prints types as a string, and it's not like magic. It's just asking this object to print itself as a debug string using this particular type of format trait, and that code is implemented at compile time by this debug macro. And the reason that this derive macro is handy is, most of the things you're debugging, you probably just want to print a fairly standard format. Like you want to print like the name of the object and then the contents and maybe some braces around it or something. And debug just gives you all that for free. But if you're doing something weird and you want to have a special way of debugging it, like I actually do this in the virtual file system, because the standard debug derive for this would just print out all the inodes in a big array, which would be correct, but really useless. It'd just be hard to read and not actually helpful. So instead, I leave off the derive debug here. There could be a debug in this list, but there isn't. And instead, I think the implementation's down here. Yeah, implement format debug for node. So this is implementing a trait. Format debug is part of the standard library or the core library. And then this formatter is actually it's like a interface for the object that the macro generates with the list of formatter arguments. It's in fact the same thing that this formatter args macro is creating. So this is actually this is not even that complicated. This is formatting individual nodes. There's also a debug formatter for the whole file system, which is what I was actually looking for. And so this actually goes through the list of. Oh, this is actually. I think this is actually traversing the directories. It's not going in inode order at all. It's using a stack of directories that it lists. So this can just implement kind of arbitrary logic, and then internally it's using the formatter support of some of the child objects. So like that would actually end up using this formatter for the node. So it's a pretty handy system. And then serialization. So in addition to code for formatting or copying or whatever, debugging, these protocol data types here have these derives for serialize and deserialize. Those are super handy. That's part of a Rust library called serde for serialization, deserialization. And so serde by itself doesn't know about any specific serialization formats. It's just like a way of generating code to kind of walk through data structures in a methodical way. So the serialize and deserialize traits that you saw in that other file, those are generating basically like introspection interfaces. So a way of saying, hey, object, serialize all of your contents to this particular serialization interface. And that serialization interface might have methods like, start a new grouping of objects or end a grouping of objects or add a new like key value thing. It's like pretty generic as far as it can be. And then there are specific implementations of serializers that target like JSON or protocol buffers or whatever. And actually, protocol buffers are weird. I don't think you can do this with protocol buffers, but most serialization formats, you can describe the format in Rust code and then use this serde framework to automatically generate the linkage between that Rust object and some binary or text serialization of it. So here I'm actually using, I'm using a very simple serializer called SS Marshall for super simple marshaller or something like that. Yeah, stupid simple value only marshalling. The the reason to use this is that it does not require a memory allocator. So it's good for like really low level, no standard library code. So I'm using this for the protocol between these two processes. But then using the same serialization framework, I can also deal with much higher level protocols like JSON. I think a bunch of this Docker registry stuff here is using... Yeah, these are all JSON structures. So like this runtime config, image config, these are all straight out of the Docker API. So these are all like JSON files that are part of the container image. So like this image config, this is like the JSON that is sort of the canonical entry point for the image. This is a Docker file system, not my virtual file system. And it's handy. Like you can, these are some bits of metadata that are optional so that you can rename things. In this case, we wanted this to follow the Rust naming conventions, which are kind of more like lowercase and underscores. But this is what the file or what the field is actually named on the wire, that kind of thing. Like dealing with some uppercase names, regularizing all that. Yeah, I like Rust. So we're using that whole thing to serialize the messages. That means within the limitations of the serializer, so the particular serializer, because it's designed to not require dynamic memory allocations, it doesn't handle basically variable length types. It doesn't serialize like strings and arrays. But I think that's mostly fine. Like, I think given that I want this to be fairly like locked down from a security point of view, I think I'd want to be staying away from variable size objects anyway. And a lot of things that seem like they might be variable size, like, you know, like a file name, for example, like, are we actually going to be passing file names, or are we going to be passing pointers to C strings in mapped address spaces, right? Like, I don't know that we need to be passing any of the actual sub-process owned data here. I think the IPC messages are mostly going to be metadata, like file descriptors and memory addresses and things like that. I think it'll be like, here is a virtual process ID that I would like the memory map for, and then the response is like yes or no, and an error code maybe, and a file descriptor maybe. Oh, it's got a recommendation. Yeah, Mind Chisel on Twitch chat says that they have a project with a protocol that they share between an STM32 microcontroller and a PC. And the whole protocol is pretty much just some structs and enums with derive, serialize, deserialize on top, and it's so nice. And they also recommend Postcard as a super nice serializer, deserializer for embedded stuff. I'm going to check that out right now. Postcard. Yeah, I'm definitely not married to this SS Marshall thing. It's just like something I found that fit the job. This is not designed for like long-term binary compatibility, but because the endpoints of this protocol are in the same binary, I completely don't care about that. So like anytime you update the runtime, you'll also be getting a new sandbox binary and vice versa. So there is no necessity for cross-version compatibility there. Postcard. Oh, it is no standard. I wonder why I didn't find this searching earlier. Oh, this might be my new jam. Thanks for the recommendation. Yeah, this might be able to do variable size arrays if I actually end up wanting to do that. I still might want to stay away from for all the reasons I just mentioned, but it would be cool to not have a limitation in the serializer for that. I'm amused at how many different names there are for the exact same way of storing variable length integers. I think a lot of people call them var ints now because Google started calling them var ints, But Google did not invent this data type. Like, debug symbols for ELF binaries use this all over the place, and they call it LEB 128 or Little Endian Base 128. In fact, there's a crate with that name, if I remember right. I think I'm using it somewhere. Yeah. I'm pretty sure that this is the same as Google's variant. They're just different names for the same thing. Got another request for context. Mostly just hacking around on low-level Rust stuff. The big picture here is trying to work on peer-to-peer decentralizable video, live video specifically. But these individual pieces that we've been hacking around on are sort of an IPFS-flavored video server and a super experimental Linux sandbox thing written in Rust. It might be fun to just try dropping this in. I bet it just works. Heapless. That's probably a crate that I would find useful too, huh? There are a couple of places where I have something that like looks a lot like a vec, but I'm not using a vec right now because I don't want to allocate memory. That's pretty nice. It's also a cute name. My processes are sending postcards to each other. That's weird though. I guess it requires the heapless vec. I was kind of expecting a way to serialize into just like a mutable slice or something. Oh, is this what I want? Oh, okay. Yeah. I don't know why I didn't see this. Yeah, it's probably just a drop in. Let's try that. I need to do this on both sides. On default features, I think. Oh, I need to look at heapless. That's great. I probably should have used this for my seccomp thing. Although I mean, I guess there's a case to be made for keeping the dependencies light. The most actually complete thing I've put on crates so far is this little seccomp library that I pulled out of this bigger project. And that one has like a fixed size buffer thing that could almost certainly be a vec using that heapless library. right? Wait, what? Ooh, that's weird. Is there a way to specify arbitrary integers, or do you need a type for the integer? I like data structures that don't allocate, though. I like that a lot. That is... I don't know how I feel about this, though. Like, I mean, yeah, the number I want is probably in here, but ugh. Why? There's I feel like I don't know if this is actually still necessary though. Aren't there ways to associate constants with types in Rust? This is like getting into parts of Rust that I definitely have not learned yet, but gosh. Curious if there's any rumblings in the repo toward moving to something with associated types or whatever that feature would be. Oh. I thought docs would link the repository. Somebody said they're going to change this likely with Rust 1.49. Maybe I hold off on making this library dependency until they come up with a better solution for that. But it's nice to know that this exists. Just not sure if I want to use it in its current state. We could still try postcard. It's a bit of a distraction, but I'm kind of digging it. I think I just want to turn off all the features though. I could use more features over here because I have a standard library, but I don't know that I care. I think we don't actually need them on this side. Oh, that's right. I think I don't actually use SS Marshal outside of the protocol crate here. I'm just pub using these. So if I wanted to, I could actually define new serialize and deserialize functions that use the same interface right here. I don't think the interfaces quite match though, and I don't know that I care to make them match, given that I don't really need to dig into this to SS Marshall any further. I kind of like that. The other API would return an integer indicating how many bytes were used, and splitting the slice feels like a nicer API. Yeah, let's not bother with compatibility here. I don't even think I need to use right there. What is this Cobb's thing? Oh. I wonder where this comes from. That's interesting. They're encoding the zeros by replacing them with length bytes. It's an interesting trick. When they said byte stuffing, I was thinking about like the byte stuffing that I'm familiar with from like USB, for example. USB uses bit stuffing, but this is an interesting approach. think we just want to do this for a sec. I don't see where this is returning 2 slices. Maybe they changed the API and it doesn't match the comment anymore. I think it's always safe to unwrap this for now. That probably needs a cast. I don't know. Actually, conceptually, that feels nicer, but in practice, I don't actually want it taking the slice and then I would like to retain ownership of it long term. Yeah, I don't know if I care enough to switch serializers right now. It's nice to know this exists, though. Okay, I need that change. All these others. I might just revert all that and then fix the E again. Sorry, I'm just a little behind on chat. Do I need to own the buffer behind the vec, or could it be borrowed? I'm not sure what that was in reference to. You mean on the side of this where I have a memory allocator, or the heapless vec? Yeah, sorry, I'm a little lost there. Oh, interesting. Jarrett says that Rust 1.47 is just starting to implement generic types with integer parameters, which is apparently what it's called. But only for slices and only in the standard library. Alright. I should check this in before I break it further. So I am receiving my 2 no-ops here, which is what I wanted. Got my receive message and my no-ops. I think I just need to fix my SIG.io now. Yeah, F set on. I'm definitely missing that piece. So I've got set on, I've got async. I've got the actual signal handler. It just looks like such a pain to use this with threads. The above behavior was accidentally dropped in Linux 2.6.12 and will be restored. Yeah. That's why we have set on EX. Oh, interesting. Yeah, we can sidestep all of that by not using threads and keeping this simple. I don't think we need set sig. This is super interesting to keep in mind, though. I was looking at this, and this is... I could be mistaken, but I think this is a way to use a file descriptor to do arbitrary signal delivery. So like in the context of like if you're building a system call firewall and you're trying to keep a subprocess from sending signals, you can't just block the kill system call because you've got stuff like this where you can just like ask something else to generate signals for you. This is why I've been doing a lot of grepping in the Linux source code. It's like if I want to know all the places something's used in Linux, you kind of just have to look at all the Linux code. for sockets. I wouldn't expect this to only be for sockets, although I do plan on using it for a socket. Tuco's still trying to find something to get into over there. Tuco, honey. Hey. Tuco. That was quite a noise. Hey, are you looking for wires to chomp now? He's chomping on these tiny Cat6 patch cables that aren't fully protected. Oh, honey. God. You're such a god. Yes, Tuco chews on most wires, though. He certainly chews on cat cables, but he chews on cables that weren't even made specifically for him. Turning them into Cat 7. Yeah, if I could make the Cat 5 cables go faster by putting in speed holes, he'd be helping a great deal. Alright, these are all F control. Why did I make ZFL separate? Oh. I think this was because the actual F control has a variable length parameter list, which I did not want to represent in Rust. Tuco, what are you doing, honey? Oh, he is looking for trouble. Hey. I've spent a lot of time cat-proofing wires the way this studio is currently set up, but I feel like Tuco is trying his best to find something to bite. Tuco! Is he biting just like a giant bundle of covered wires back there? Tuco, honey. He's just like sinking his face into these piles of wire. No. Oh, gosh. If he bites these wires even with the cable protectors on them, I've got a problem. I might just have to lock him out. Hey, honey. Hey. He's leaving for a minute. Do any of these have multiple arguments, or is it always 1 or 0? Let's just assume these are one argument. I haven't decided how I actually feel about PIDs, like who should be allowed to use real process IDs and who should be allowed to use virtual IDs, and how those are really dealt with in this sandbox process. So I've just been making the direct system call for now. Hey Tuco, you're back already. Oh, hey Tuco, I'm sorry. Hey. You went up? That was some good purring. Tuco. Tuco brought a cat toy in here and it's shedding bits of feather all over the place. Oh, is that a real SIG.io? I think that might be. I was generating a synthetic SIG.io to test signals a little bit earlier, but I think we've got a real SIG.io as soon as this NOP was sent, which is great. And then another receive message. It's kind of hard to test this without being able to leave it running. Like if I was just testing out the IPC server, what I'd really want is for it to be blocked in wait ID, like waiting for ptrace messages, and then to verify that I can asynchronously send it something over the IPC channel and wake it up. But I don't know if it's better to try to make a test harness for that now, or to just wait until we're actually at the point where that's an easy thing to do. Yeah. Tuke's got the best noises. So we are not using the SIG.io to do anything other than print out the message and to wake up from the other system call, but that's already probably sufficient just to like get to the next stage of this, because we don't actually need to do the I/O on the signal handler. We just need the signal to wake up the other system call. Oh, Tuco is definitely looking for stuff to bite. Honey. Maybe Tuco should be outside for a little while. I don't think Tuco can open that door on his own. Yeah, it's just asserting that the signal number looks right and then printing. So one thing that might be kind of nice to do in sort of an intermediate capacity is even if we're not doing the actual I/O on the signal handler, it might be nice for the signal handler to set like a global flag that indicates that we've seen an I/O signal, and then we can only poll the socket at all if that flag is set, which will save us some system call overhead. That gets a little messy to actually implement because now that's some like random global state that doesn't have a super well-defined like scope. It's just has some I/O thing happened. You could make that a little bit more general purpose, maybe a little less weird, by using this like the SIG.io, what is it, the SIG info that you can opt into getting from Signal. You can use one of those fields to figure out what file descriptor caused the wake up. So you could use that kind of more like a normal event loop. Like notice that you've woken up, that you've interrupted a system call like for a particular file descriptor, and then run some handler associated with that file descriptor. Given that this is just a very special purpose program, though, I don't know if it makes sense to do much of that. I can't think of like what else are we interacting with from the tracer? Like most of the I/O is memory mapped or ptrace, and then there's this IPC channel. I don't know what other file descriptors we'd be waiting on. So for stuff like loading a binary. So like one of the thought experiments I've been going through is like, how does exec work? You know, like you're either already in the sandbox and you're execing a new process, or you're in the sandbox loader and you're execing the first process that's actually in the sandbox. Either way, that looks like an exec sys call that gets trapped by the ptracer. And I think I've established that there isn't a really a viable way to have the kernel load the process still, like at this point, given that we've got like a totally virtual file system. I think it makes the most sense to build our own elf loader out of just like memory mapping components. One option would potentially be to use that memfd create thing again, and then make like a separate fd. The problem with that though is that I still don't think we have a way of actually launching the kernel's loader safely, because we would need to do it in a way that like we're firewalled off from executing arbitrary processes, but we can still execute stuff from memory. So like one way to solve this would be if there's a way to use seccomp to firewall off exec system calls that refer to paths other than a very specific set. So maybe you're allowed to exec anything that starts with like /proc/self/fd, for example, but you're not allowed to exec like other random stuff from proc, and you're not allowed to access like other parts of the file system. There's just not a way to do that with seccomp, because that all involves checking the contents of data structures that are pointed to by system calls, rather than actually checking the integer values of the system call arguments. And I don't think there's a way to do that really. The seccomp program itself can't just access arbitrary user memory. The tracer could access user memory, and the tracer could make sure that the string is safe before issuing a system call, but like it would still have to issue that system call, and so like the tracer itself would need privileges to run exec, and I don't know if I want to allow that. Like giving the tracer privileges to exec an arbitrary process, what would that actually involve? Because it's not quite like a hole all the way through the sandbox, right? Like, let's say you get arbitrary code execution in the tracer, which involves already having at least one other vulnerability in this stack. But let's say you get code execution in the tracer, and you want to just like exec bin sh or something. You know, maybe you set up some arguments or some environment that would have it run a script on your behalf that does some nefarious things. The process that you exec off, though, still has the same seccomp firewall that the entire tracer has. So let's say we have to make an exemption that allows the tracer to run any exec. The tracer could run like bin sh or something, but then bin sh would still be running with the same privileges that you would normally have. So the question is, could you use just the loader itself for nefarious purposes? Like, could you load a file that you're not even supposed to like have access to, and then let the kernel map it into memory for you, for example? And maybe there are scenarios where that's okay. Like maybe I think about this some more, and there are ways to use the kernel loader safely. But my gut feeling at this point is that that's kind of danger zone, and it would be better to lock things down such that only memory mapping is allowed, and then build the elf loader out of memory mapping. Because if you can like set the CPU registers, which ptrace gives you, and if you can map memory, then you can load processes. Actually sure how I would make some global mutable state in Rust. Rust really tries to keep you from doing that kind of thing. Can I have a mutable reference to a static value? Tuco wants back in. It's also kind of awkward because this object, this socket that I've created here, it doesn't, like, it's just like, it knows how to read and write, it knows how to serialize and deserialize messages, but it doesn't know about control flow, really. Like, it doesn't know when it should be getting called. So I feel like the SIG.io stuff should maybe be part of a slightly separate layer, even though this is really the only socket we have in the program, and probably will be the only socket. We are about at the 5-hour mark here, which means maybe I should think about doing some human things like eating. But I think I got a bit more of this in me, if folks are still into this. Like, it's almost like what I want is something that looks kind of like like an event loop reactor kind of thing as far as its API goes, but like its actual implementation could be super simple because we have like exactly one file descriptor in this program. That's not true. We have one file descriptor we want events on though. I think basically every other file descriptor we have is going to be either something that we're just passing on to the inside of the sandbox and then it's doing waiting on that, or something where we're dealing with memory maps. I don't think the sand process is going to have to do asynchronous I/O on anything except the IPC socket. So like we could implement that thing that lets us get additional signal parameters, but that might just be a bunch of annoyance for no actual benefit. What about the PIDs though? I haven't decided, well, I think I have decided that the tracer itself pretty definitively needs to know about real process IDs, really just practically because it uses ptrace. Like it needs process IDs that work with the ptrace API, which are real system process IDs. I mean, it shouldn't have permission to send signals though. Kind of makes me think I should be locking down F control, huh? Like if I lock down, like if I were to allow the tracer to have access to any F control, then I'm pretty sure you could use that to send like a kill signal to a process that's owned by the like real system user, but not by the sandbox, which is definitely bad. So yeah, this might be time to add some like more granular system call filters. We could also put all that aside until we need more of it, because we do at least have some IPC happening, even if the I/O parts need a lot of work. Like, is there a way to keep the tracer from being able to send SIG.io to other processes that the user owns? I mean, it could actually bake the process ID into the filter, couldn't it? This is one benefit of the sand process not being multi-threaded. Is it, like, during its lifetime effectively has a constant process ID. So we can just bake that into the filters and for example, we could have a setcomp filter that allows sending signals to itself, like to the sandbox itself, but not to other processes. And that might be exactly what we need here. there's so many big, interesting, substantive questions that you have to answer in making something weird like this. I find it kind of satisfying. I'm also thinking about how, like just thinking about like control flow, like how does this program run? So I'm pretty sure it's single-threaded. I'm pretty sure it's basically an event-driven reactor that's mostly dealing with ptrace events, but is also set up to deal with these IPC events. So what about the ptrace state machine for a process? So when we're emulating a system call, the process we're tracing, I guess it happens after the syscall instruction is sort of technically like decoded and executed, but before the system call itself runs. So you end up getting stopped in the state where the process has its instruction pointer pointing right after the system call, and the like on x86, the AX register will be the system call number, and a bunch of the other registers are the system call parameters. And in that state, you can just continue the process, and the system call will be invoked by the kernel. Things will happen normally. We don't want that because it's generally not secure. It's generally not what we want. So instead, Linux has this kind of weird convention where, and I don't think this is specific to ptrace, I think it's used in other places too, but if the system call is negative or -1 even, then it just gets skipped. So the ptracer can do that. The ptracer can, in the processor's register set that gets saved when the process is stopped by ptrace, it can just set AX to -1 and then resume. And then at that point, the instruction pointer will be pointing right after the system call. The kernel will have not implemented the system call. So if you write return values into the registers as if you just emulated the system call, then now you can just continue from that point. So that's what we want. We've got most of that. I mean, the tricky part really is when you start needing to emulate system calls asynchronously. So a single process can only do one system call at a time because that's just its control flow. That's where its instruction pointer visits. But this one sandbox this one like sand binary is managing an entire sandbox, which is likely many processes, multiple threads in one copy of FFmpeg, for example. So I suspect a lot of these system calls will be pretty simple and will turn into maybe like a single IPC operation, if any. So let's say we're opening a file. That open system call probably turns roughly into an open IPC call. So we would tell the runtime, hey, someone inside the sandbox wants this file. If you feel like giving it to us, then send back a file descriptor and we'll get it to the right place. And that's what it looks like on the IPC level. But then, that's pretty simple, right? As soon as the IPC completes, you can complete the system call. So there could be a one-to-one relationship between a lot of these events. Like the event where you stop on an open system call matches one-to-one with sending stuff out over IPC. The send right now we're using, I think we're just assuming the kernel buffer never fills up because I think it's a non-blocking send, but we're just asserting that it succeeds, which is also not great. The flow control that we're talking about is usually receive, but sometimes we have to think about the send end also. Yeah, I think a more interesting thought experiment than open is something like exec. So if we're implementing exec using a bunch of separate memory maps, right, rather than just telling the kernel to open a particular binary, because we need to we need to go through our emulated file system, and there isn't a way to just point exec directly at a file descriptor or at a chunk of memory. Like, it needs a path, and it doesn't seem like we can do that safely. So each of those memory mappings is going to be a separate trip through IPC. Like, maybe there's a different way to do that. Like, maybe if we really had to, there could be a way to make sure that every system call mapped one-to-one with an IPC call. So you'd have like a prepare exec resources system call or something, and then a complete exec, or sorry, an IPC call, and then like a complete exec, like IPC response or something. I really don't like that though. Like, I would rather have fairly arbitrary composability so that you can make just a basic mmap IPC and then use that to implement a basic mmap, but then also build something more complicated out of the mmap when you need to. So anyway, where that leads is that now you start having cases where you're tracking the state of sending and receiving multiple IPC messages while the process that you're running inside the tracer is still waiting on a single system call. So I wonder, like, is there a way to use async Rust with no standard? Is it better to just write state machines for that? It'd be very interesting to see if async and no standard works together. That would be pretty cool. And if that does work together, like, how much of my entire event loop do I want that to be? Like, do I start converting the wait ID and SIG.io kind of stuff in here to use futures? Like, I've used Tokyo and async standard in Rust, but I have not written my own async runtime yet. That might be an interesting thing to like at least look and see how it's done. Mantrazel in Twitch chat says that they think folks are using async and no standard together. Yeah, I should at least check crates to see if that's still happening, huh? Oh, thanks so much for the kind words. To research Rust. Oh, this is brand new. That's cool. And of course, people are doing this for microcontrollers. This seems like it would be amazing on microcontrollers. It kind of makes me want to start an embedded project just to play with this, actually. Oh, that's handy. Oh yeah, I'm using Nightly for the sand anyway. The way this project currently is, the outer piece, the runtime, that compiles fine on stable Rust, but the inner piece, the sand, requires Nightly Rust. I think there are multiple reasons at this point. The biggest reason, so some of this is just like no standard stuff. The panic info message and naked functions are definitely unstable features right now. Naked functions I needed for signal handling. Specifically the signal restore function, this thing, sig return. This has to be a naked function because the way this is written, this gets called by a stack frame constructed by the kernel during signal dispatch. And I don't know, there might be a way around this because like I'm definitely not an expert in this part of the kernel or the libc or whatever. But how this usually works is you when you're setting up a signal handler, you fill out this sig action structure. This all happens inside libc. So the standard library would have this signal function in it. You just pass a handler to and a signal number. It would construct one of these sig actions, which has a very architecture-specific definition. And there's some optional features in here we aren't using, like we're not masking off any signals. This restorer is another architecture-specific feature. And I thought it was actually optional, but on x86, the kernel will just act like a seg fault happened if you don't set sa restorer. So they specifically want you to set that on x86, 64 at least. So like this is all working on the return path from a signal. To get into a signal, the kernel kind of creates this synthetic stack frame during a normal system call return or asynchronously, I think. I forget how the asynchronous stack frame construction works. But normally signals, I don't think that's true, actually. I think signal deliveries are always on the return from a syscall. I could be wrong about that, but I'm pretty sure signal delivery is always on the return from a syscall. And if a system call is in process and it's blocking, the system call gets interrupted and returned. If you're not in a system call, if you're just executing user code, I think it won't interrupt you unless it's sig kill, but I could be wrong about that. I don't actually know how asynchronous signal delivery works, if that's a thing. Right, because like the kernel would need to know where it is safe to write to on the stack. It's not an easy problem. Oh, that's an interesting question. There's a C++ dev here who got some cold feet about Rust after all the Mozilla layoffs and is wondering if they overreacted. I don't know if I'd say that was an overreaction. I mean, the like Rust layout or the Mozilla layoffs certainly suck, but it seems like there are a lot of folks using Rust and contributing to it, and I'm certainly expecting and hoping that that regardless of what happens at Mozilla, Rust will still be a pretty compelling language for like a lot of people to do the kinds of things in now that we're kind of stuck writing C++ for. Like I've definitely just like in this time that I've been kind of like learning Rust kind of slowly over the past couple of years and using it for like little things here and there. I've still, I've started projects in C++. Like while I was working on the Tuco Flyer stuff in Rust, I was still writing like microcontroller code in C++ and writing like OBS plugins in C++. But that was a few years ago, and I think after, I don't know if it's my feelings on Rust or my feelings on C++ or the state of the Rust ecosystem, but things have evolved such that I have a hard time imagining myself starting a new project in C++ right now. I feel like, regardless of what happens with Mozilla, there's a lot of momentum in the Rust language team and on the Rust libraries. And I've just had an easy enough time getting Rust to interoperate with C code that I'm not super worried about being in an environment where everything has to be in Rust. As long as I can write pieces of something in Rust, that seems like an improvement. Oh, thanks. Aaron says it's good to see me streaming again, and they've been watching my Drobo repair, and that the firmware's pretty interesting. Yeah, I should maybe get back to that stuff a little bit sometimes. I still have that that other Drobo that they sent me that I was going to do like a teardown on and maybe send out as a as like some kind of giveaway object. But I think that was still pre-COVID that I was thinking about that and pre-move. But yeah, there's no reason not to do that, really. Mine Trizzle says that Rust Embedded has gotten so good over the past year it blows their mind. Yeah, that's pretty cool. I'm anxious to try more Rust Embedded. I've certainly been enjoying the like high-level and low-level computer programming parts of it that I've seen so far. Like this no standard stuff, like this is great. Like I know some of it looks terrible, but it's like the fact that this is as nice as it is just makes my day. And then the stuff in the runtime, like some of this is just nice, like being able to do all this like high level kind of HTTP stuff is very handy. And then serialization, like, yeah, I mean, I can't think of another language I'd want to be writing this in, really. I mean, if I felt like writing Go code, I could probably yank a bunch of pieces out of gvisor and use that, but I think I'd rather use Rust at this point, even if it means getting to write some new code. And, you know, maybe I give up on this and just like hack at gvisor and make it do what I want, but so far at least I've got momentum and motivation to try to make a cute little Rust sandbox thingy. In general, though, like right now I'm thinking maybe I need to take a break and get some food soon. Oh, that's another good question. Oscar is wondering what software I'm using for the chroma key. This is OBS, Open Broadcast Studio. Looks kind of like that. Yeah, this is what my stream setup looks like right now. I've got OBS, I've got Ableton doing the audio, I've got this synchronous audio router thing that's connecting the audio on Ableton to the audio on OBS. Got a bunch of scenes over here, a bunch of sources, just typical OBS stuff. I can't actually show you these by clicking on them because it'll switch sources, but if I went down here and like I've got sources that just do the compositing. So I've got, scenes. I've discovered that OBS is much easier to manage if you just create tons and tons of scenes for stuff and then use nested scenes as sources. Seems to be much easier to keep things in, in a good spot. Oh, that's right. What I can do, composite, oops. I can right click on that and put it in a window and then go back to my other view. So I could do stuff like that. Yeah, there's a little bit of color spill, but I kind of spent a moderate amount of time fussing with the controls and then left it alone. Oh yeah, what am I doing to the audio in Ableton? Mostly mixing. I mean, Ableton is super overkill for it right now. I like when I'm doing these live shows, it's basically just like mixing and a little bit of EQ sometimes, but when I'm doing like recorded stuff, sometimes I'll plug an instrument into that or like use it for something slightly more complicated. But I'm using Ableton mostly just because I had it handy and I'm familiar with it. It could be a simpler mixer kind of program, probably. The submarine window behind me. Oh, that's actually a video I took of my previous studio. If I'm thinking of if you mean the like window that was behind me. This thing. Yeah, this is actually just like a fisheye view of the view that I had out the window at my old place in Emeryville. And it's just like a random video that I thought would make a good background for this, really. It's a couple days of time-lapse video in a loop. Blown up like this, you get a lot of fuzzies around the green screen edges. But I could be adjusting the video more, but I'm not. Yeah, so I think my head's still kind of in the clouds thinking about async and no standard. Jared's wondering if there's an issue with the Rust syntax highlighting. Yeah, there is. There's something wrong with the Rust syntax highlighter here. This is the Atom built-in Rust syntax highlighter. I think Emacs handles it fine. Where are we? IPC server, task. Runtime. not as pretty, but I've got this. Scrolls by these large jumps, which is not always what I want. Gosh, this color scheme gets a little bit mashed up by the YUV. Kind of reminiscent of editing text on an Apple II or something. Well, it might be fun to look a little bit more into this like async embedded stuff, but I might also be trying to wrap up the stream soon and then get some food. The archives for these streams, they end up on YouTube, and I also always put them up on Diode Zone. That's delightful. I love it when LLVM does that. It just constant folds everything. Yeah. Opt-in heap. Gas-powered heap. Never runs out of heap. I certainly could choose to use a heap. Like the no heap thing is mostly just because it like what do I need a heap for? Kind of, you know, like if I really wanted a heap, I could add an allocator. It wouldn't be a big deal. But I like how easy it is to keep it simple right now. That's pretty nice. Oh, that's handy too. Yeah, I've used this async trait macro just a little bit, but I didn't realize what the overhead was. Yeah, I need to figure out how global mutable data works too, because like if I'm doing any kind of like IO reactor kind of thing, it's going to need information about what the currently waiting things are. So there's going to need to be some kind of global state for that. Just me wading into the parts of Rust that I have not yet waded into. Gosh, I wonder if the Rust consulting gig is a good place to be. Like, it seems like that's what they're doing here, right? When you see AST lowering, you know you're getting close to the LLVM code. Oh, yeah, I should check that out. Mindtrizzle says that a lot of the Ferris folks hang out in the Rust embedded matrix channels. Yeah, there's a lot. I should actually try to do better at like making online friends who do Rust stuff, since it does seem like Rust is so far the brightest spot in the whole field of computing. Ah, why? Why are we choosing names that are identifiers and have to be escaped? Anyway. Also, what is the H in hprintline? Oh, host. That's interesting. You know, I hardly ever use semi-hosting. I probably should. It seems useful. It's a thing where when you're writing microcontroller code, there's a standardized way of getting messages back and forth between your code and a debugger, and you can do things like print debug output and read files and stuff like that. That's cool. Oh, that's a good question. Someone was asking what these like octothorpe hash things are. I forget what the technical name for that is. These are like kind of special language items, but like sometimes they're macros, sometimes they're kind of like attributes. I feel like I should know what they're called, so I'm gonna look it up. Oh, maybe I want the syntax reference. Oh, this is calling it an annotation. Is that what their actual name is? Lifetime annotations are different. It's probably safe to say they're called annotations. Oh, this calls them attributes. I think attributes are their real name. Oh, I didn't realize these were literally modeled off of the C# syntax. That's cool. So yeah, it's just like a way of adding kind of extra information to objects in a machine readable way. Kind of like allowing easy extension to the language. So some of them are like parameters for the language, and some of them are macros, kind of depending on context. I mostly just want to read the code for the task executor. Right, like task block on and task spawn are the really interesting pieces here. Like task spawn has to be storing this future somewhere where it can be pulled in the future. Probably allocates memory. And then block on is doing something similar to this future, but then waiting for futures to complete by running the event loop, which is what we're actually trying to do, is run the event loop. Unsync. I'm curious where this specific module comes from, but it looks like a really lightweight version of some of the synchronization primitives that are usually available. And tasks. Oh, this is another one of those weird things where we're using a type as a number. Right? Because like I think a lot of people in this case, oh, you need a constant value, you use a constant, but that's like a constant you can read at runtime, whereas I think this is used for the parameterization of types, and so technically it needs to be a type and not a value. It's just awkward. Oh, how does executor current work? Why are we building a V table? It looks like the executor struct is going to be where all the shared state happens. Yeah, this is a singleton. Only works outside of interrupt context in this example. It's interesting too. Gosh, I wanna play with this now. It's like an excuse to write some more ARM code. Oh. Yeah, these are some pieces that I need to learn too, like unsafe cell and maybe uninit seem super useful. I should read about them. That's handy. Okay, so some of this is pretty predictable. Like we have a way of figuring out how to return control flow where it needs to go. Which is, I think, what this vtable is for, but I don't know. And we have a way of making this a singleton safely. Oh, that's from libcore. Core task does seem to be the place to start here. I mean, I imagine this is the same as standard task, but I don't actually know. I haven't looked at the innards of standard task either. If you're not familiar with this part of Rust, standard is the standard library, but then core is a subset of the standard library that doesn't require like really any operating system features. So it's the sort of minimal Rust that you're programming against for embedded systems or for environments like the sandbox here where we don't have access to the standard C library. Yeah. It's probably not super interesting to just stream me reading documentation all night. Oh, Mindtrizzle says that maybe the that raw token thing was breaking the syntax highlighter. I must have missed that. I've definitely seen the syntax highlighter breaking on weird, like what is even this? I don't see what's strange about this. Like this is a macro invocation, but like there are plenty of macros that aren't broken. So I don't know. I don't know what the syntax highlighter's thinking. Those raw, what are they even called? Like when you escape an identifier, like this. Like I wouldn't be surprised if that breaks some syntax highlighters, but so far I'm not sure if I've seen that. Oh, hi Alexis, nice to see you. I'm really curious what all this is about. Like I have not looked at the innards of like I guess standard task before, but like this is interesting. Is there a document on just like what it's like to write a Rust task executor? Hmm. The new hot thing. It would just be super nice if I could make my system call emulator use async rust, and I could asynchronously issue IPC calls while emulating a system call. That just seems wonderful. Like that seems like what I need to make this not terrible. Like if I have async, I can actually make my IPCs look like calls and not just messages, and that might be nice. Like right now, it's really more of a message passing system than real inter process like procedure calls or anything like that. Yeah, I mean, I still am having mixed feelings about how useful the weird experimental sandbox project is overall, but it's certainly a great way to learn some really interesting parts of Rust, and that's been pretty neat so far. Um, if you're watching this either live or in the archives, do let me know what you think about kind of future streams on either the like video server or the sandbox sub projects here, if you think that might be interesting, or if you just think all programming is boring and I should get back to hardware. I'm gonna see if I can let Tuco in for a bit of a cuddle, and then maybe we'll wind down and I can just read a bunch of source code offline. Hey Tuco. Hey, come in. Hey. See if I can set up the cat cam here. Oh, Tuco. If you go out there, I can't photograph you. Well. Hey, Tuke. It's almost like his priority is not to be on camera. Do you want to be on the chair, Tuke? He's rubbing his face on the chair just off camera. Hey. Do you want to sit down? Such a good little tiger. Yeah? Oh, maybe Tuco wants to hang out. Programming is cool. I love to type. Right? I can't tell how serious you are, but I feel like I agree regardless. Yeah, I was getting really into just like writing code the last couple of weeks to the extent that I was starting to really mess with my hand. Like I was having some kind of concerning pain, so I had to take it easy for a couple of days. I think some of that was from typing too much on my laptop instead of on the like proper ergonomic keyboard. Apparently that was very serious. That's cool. Yeah, I should get more into keyboards maybe. I mean, I have one pretty nice like ergonomic split keyboard, which I should really just use more. It's partly that thing where it's only on one computer, and it's partly that thing where I'm still a little slower on it than I am on a regular QWERTY. He is just so chill. Oh, thanks for the super chat, CRC1337. CRC Elite. Is that a 16-bit or 32-bit CRC? Gosh, Tuco's comfy. Usually doesn't stay on my lap for this long. My leg's shaking and it's not entirely easy to control, but Tuco doesn't seem to super mind. Gosh, I wish I could share with you all just how soft Tuco's head is. He's been pretty chill lately, you know. He still gets in his moods where he needs something specific, but like in general, I think he seems to be really liking the spot here. There was even a neighbor cat. I haven't seen him in a few days, but for a while he was he was coming by like every morning, and Tuco and the other cat seemed to get along. Like they would look at each other through the door a lot, and a couple of times I brought Tuco outside on a harness and they interacted a little bit and they seemed really friendly. Which is like, I'm surprised Tuco didn't hiss at all. Like usually some politics happens between him and other cats, but they seem to just hit it off right away. I can't believe he's still relaxed. He's shedding really bad now and it's getting all in my face. I'm probably just gonna sneeze and he's gonna get up. Yeah, we had a lot of cat politics at the old place. Between Tuco and the temporary cats and the neighbor cats in the building. I think the cat that was visiting in the yard probably lives at one of the houses, a couple houses down on the same block. But I don't know for sure. It's possible they're just totally outdoor cats, but they seem pretty well taken care of. if you've ever used Signals for I/O notification, leave a note in the comments. I'm kind of curious who else has ever tried this, because it seems like such a weird esoteric corner of Unix. Oh, did I scare away too good with the computer talk? Or are you still cozy? Hmm. Gosh. What a lovely little fuzz. Gosh, he's never this relaxed. Gosh, an async Rust system call emulator just seems like fun. Oh, so much cat fuzz. Getting up. Oh gosh, I'm covered in fur. Tuko, you should be brushed more often, maybe. Ugh. So much fuzz. Alright. Well, maybe I should wrap this up and go play with Tuko a bit and then read some more docs and code. Well, thanks so much for stopping by and hanging out with the stream today. And a special thanks to all my patrons who make it possible for me to pay my electric bill and health insurance and continue doing this as much as I can. I'm always feeling like I'm not doing enough to put content out there for people. So, like, if you have specific things you want to see, feel free to let me know. Or otherwise, I'll just keep trying to break down the barriers to doing this and actually do it more often, and maybe make like a daily or at least several times a week thing of this again, because that was pretty nice. And I feel like one of the things that was hard about this last time is that my studio setup was extremely temporary and there were just wires all over the place and it was terrible, and I've basically fixed that since last time I streamed. The wiring, like, gosh, I didn't even mention this on the stream. I did so much wiring work. There's actually all these, maybe I can show you on this other camera. There's all these conduits that just take video and take them from place to place. So, what we got? So green screen, I just painted that the other day. It's still pretty nice and new. Green light. That's where I was just sitting. And then kind of an editing workstation over there. This is like a cute little equipment rack with the audio interface and a patch panel and a bunch of USB to Cat5 converters and stuff like that. It actually has a big old cable coming out of the back, which is somewhat hidden here. It's that orange thing. So that is a 2-inch diameter Carlon Resiguard tube. It's often blue, so it gets called Smurf tube, but the low voltage stuff is orange. So that goes over here, up there, into the ceiling, across to the other side of the house, and then into an equipment rack where all the actual machines are. So that keeps most of the equipment for this out of this room, and the wiring is no longer on the floor, but is actually substantially going through the roof, or through the attic. This is also the camera that I'll be using to do electronics streams once I'm back on that more often. All right, well, thanks so much for stopping by. I guess we got the fast clouds on the outro here. Got some unique weather happening there. But yeah, thanks for stopping by. I'll try to do this again soon. If you want to get notifications when the streams are happening, you can follow on Twitch, you can follow on YouTube. The live streams are specifically on the Scanlime-in-Progress YouTube channel, rather than the main Scanlime channel. And then I've also got a Twitter notifier bot thing set up if you go to the Scanlime Live Twitter channel. Those are the same links that have been on the bottom for a lot of this time. So, and yeah, thanks again to everybody for stopping by. Hope that was fun, and I'll see you all shortly. Happy hacking, everyone.